On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, we extend a very warm welcome to all our invited dignitaries, former presidents of INAE, members of INAE Governing Council, esteemed fellows, delegates, young associates, members of INAE, research scholars, and students to Annual Convention 2025 of INAE. For those guests not familiar with Indian National Academy of Engineering, INAE was established on April 20th, 1987 as a society under the Societies Registration Act 1860 and is an autonomous professional body located at Technology Bhavan, New Delhi. The Academy was inaugurated by the then Prime Minister of India on 11th April 1988. INAE comprises India's most distinguished engineers, engineer scientists, and technologists covering the entire spectrum of engineering discipline. It functions as an apex body and promotes the practice of engineering and technology and the related sciences for their application to solving problems of national importance. The Academy also provides a forum for futuristic planning for countries' development requiring engineering and technological inputs and brings together specialists from such fields may be necessary for comprehensive solutions to the needs of the country. The actionable recommendations emanating from the deliberations of technical events and the programs are submitted to concerned government department and the agencies for consideration as inputs for framing the national policies. INAE in the past has been led by many luminaries such as Dr. APJ Abdul Kalam and many other stalwarts in the field of engineering. The fellowship of INAE is a gold standard in engineering excellence. We have about 1,000 fellows on our roll and 120 foreign fellows. As the only engineering academy of the country, INAE represents India at the International Council of Academies of Engineering and Technological Sciences, CATES, a premier non-governmental international organization comprising of member academies from 33 countries across the world with the objective of contributing to the advancement of engineering and technological sciences to promote sustainable economic growth. Ladies and gentlemen, before you proceed, we would like to take a moment to acknowledge the host organization and the sponsor of the event, Hindustan Aeronautics Limited, Bengaluru. Although HAL does not require any introduction, yet it is my honor to briefly introduce HAL. It is a Maharatna public sector undertaking under the Ministry of Defense, Government of India. Established in 1940, the company is one of the oldest and the largest aerospace and defense manufacturers in the world and plays a crucial role in India's defense sector by designing, developing, manufacturing, repairing, and overhauling aircrafts, helicopters, engines, and related systems like avionics and accessories. Over the years, HAL Bengaluru has been instrumental in design, development, and production of aircraft, helicopters, aero engines, and avionics for Indian Armed Forces. HAL Management Academy, established in 1969, provides technology and management programs with a special focus on the aerospace and aviation industry in India and is the premier training and leadership development institute of Hindustan Aeronautics Limited. We gratefully acknowledge another sponsor of the event, Bharat Electronics Limited, BEL, which is a Navratna public sector undertaking under the Ministry of Defense, Government of India. It manufactures the state-of-art electronic products and system of the Army, Navy, and the Air Force. BEL has also diversified into areas like homeland security solutions, smart cities, e-governance solution, space electronics, energy storage products, solar, network and cyber security, railways and metro solutions, airport solutions, electronic voting machines, telecom products, passive night vision devices, medical electronics, composites, and software solutions. Ladies and gentlemen, I again extend a very warm welcome to this distinguished gathering, and now we move on to the award lecture session of Indian National Academy of Engineering. Today we celebrate excellence, innovation, and lifelong dedication in the field of engineering by honoring remarkable individuals whose contributions have left an indelible mark on society, academia, and the nation. As we commence this prestigious session of INAE Award Lectures, it is now my honor to invite the chair of the session, Dr. P.S. Goel, FNAE, former president of INAE, honorary distinguished professor at NIAS, honorary distinguished professor ISRO headquarters, chairing technical committee for 6,000 meter manned submersible and technical research board of Ministry of Earth Sciences. Please, sir. Thank you, sir. We now invite our eminent awardees, the proud recipients of INAE Major Awards, to join us on the dais. The recipient of INAE Lifetime Contribution Award in Engineering, Dr. Sanak Mishra and Professor J.B. Joshi, sir. The recipient of INAE Professor Jai Krishna Memorial Award, Professor Anil Kumar Bhaumik. He'll be joining virtually from USA. The recipient of INAE Professor S.N. Mitra Memorial Award, Professor Bhim Singh. The recipient of INAE Outstanding Teacher Award, Professor Sashendu De. The recipient of INAE Outstanding Teacher Award, Professor S.V. Kulkarni. And the recipient of INAE Woman Engineer Award, Dr. Geeta Manjunath. We request the audience to please join us in giving them a warm round of applause for their exemplary achievements and contributions to the engineering fraternity. To commence the proceeding of this prestigious session, it is our privilege to extend a floral welcome to our esteemed dignitaries present with us this evening. May I request Dr. P.S. Goel to please present the bouquet to Dr. Sanak Mishra, the recipient of INAE Lifetime Contribution Award in Engineering. Professor J.B. Joshi, recipient of INAE Lifetime Contribution Award in Engineering. Professor Bhim Singh, recipient of INAE Professor S.N. Mitra Memorial Award. Professor Sashendu De, recipient of INAE Outstanding Teacher Award. Professor S.V. Kulkarni, recipient of INAE Outstanding Teacher Award. Dr. Geeta Manjunath, recipient of INAE Woman Engineer of the Year Award. Ladies and gentlemen, with the chair and our distinguished awardees now on the dais, I humbly request Dr. P.S. Goel to kindly commence the session and take the proceedings forward. Thank you, sir.
Thank you very much, and good evening to all of you. I think it's already evening, no? So it's okay. We'll have first lecture by Professor Sanak Mishra. He's for his lifetime contributions to the engineering subject. He has been our past president of the INAE, and he has been a very, very renowned metallurgist in the country. Whole life he has inspired in various capacities as a metallurgist. He was a founder member of the later executive director of SAIL Research and Development Center for Iron and Steel at Ranchi. In the period 2002 to 2005, he was managing director, Rourkela Steel Plant. Interesting thing is that in this period, when he joined, the Rourkela Steel Plant was in much more loss. And by the time he left, it was making a lot of money. He was vice president of ArcelorMittal Corporate Group and CEO of its India project during 14 to 17, he served as the as the first chief executive of the India Steel Association. He received numerous awards like National Merit Award, Lifetime Achievement Award of the Ministry of Steel, Distinguished Alumni Award of the Indian Institute of Science, and Distinguished Merit Award from the University of Illinois Urbana-Champaign, USA. And he's also named him as recently as a legendary alumni of the organization, of the institution. So I invite Dr. Sanak Mishra.
Um, Esteemed Dr. Goel, the President of INAE, Dr. Jan Patil, the former President, Professor Manna, the distinguished and very eminent personalities on the dais, Professor Joshi and others, the Fellowship of INAE. I would like to first of all thank the President INAE, the Governing Council, and the entire Fellowship for the conferment of this very prestigious award. I feel humbled knowing that very eminent personalities have been conferred this award in the past. I might mention also that I had the privilege of receiving the Joy Krishna Memorial Award in 2010. An award lecture like this is a moment of thanksgiving, a moment of reflection, a moment of looking back, but also a moment of looking forward. So I'll follow that particular process. First of all, I'd like to dedicate this award lecture to my wife, Veena. She's not here because of other commitments. An accomplished information and communication expert in her own right. She has stood by my side like a solid rock for the last 50 years or more. I also recollect my late father, Sri Haryar Mishra, an eminent educationist of the state of Odisha and a writer and a social reformer. I remember at this point of time my mother, Indumati Devi, a mother of 15 children, a woman of great courage and dignity and kindness. When I was young, I was primarily inspired by my father and my mother. And I'll be inspired by what they were, what they stood for all my life, till I'm alive. But when I grew to middle ages, I also was inspired by our two brilliant sons, Apurva and Ashish, for their brilliant accomplishments. Before I talk about my own work, I would like to reminisce about my association with the Indian National Academy of Engineering, which is quite a long story. I became a fellow when President Abdul Kalam was the president of INAE. At that time, he was not the president of India. He was the, I think, advisor to the Prime Minister, a scientific advisor to the Prime Minister. I served many presidents with great pleasure, starting with Dr. Anil Kakodkar. I was a member of the sectional committee. Number 8. I was the treasurer when Professor P. Ramarao was the president. I served Professor Goel here, Dr. Goel, When he was president, I served him as vice president. I served my close friend Baldev Raj as his vice president when he was the president. I served also Dr. B.N. Suresh as vice president when he was the president. When I became president, I was supported by very eminent vice presidents. Professor Manna, who later on became the president, Dr. Pradeep, and Dr. Purnendu Ghosh. Later on, I was a member of the Apex Committee. I had the pleasure of working with Dr. Shivaji Chakravarti, Professor Shivaji Chakravarti, Professor U.B. Desai, who were the vice presidents, who still are the vice presidents. When I was the president of INAE, I had also the distinction of serving on the executive board of CATES, the Council of the Academies of the Engineering and Technological Sciences, and I was a member of their strategy group. I am also very thankful to a number of executive directors who served INAE with distinction: Brigadier Marwa, Brigadier Minocha, and now Colonel Rai. I am also thankful to Sri Anant Krishnan. He is not here. When I was vice president and president later on, INAE went through a very large-scale digital mode. We went into a digital platform and digital mode. Anant Krishnan, who was the CTO, the Chief Technology Officer of TCS at that time, gave me tremendous support along with Dr. Pradeep. And so I think when the COVID came in 2020 March, INAE was already well prepared to handle its business as usual through these digital platforms. I am also thankful to the staff of INAE who has stood at the periphery of disaster during COVID, and they really made sure that INAE kept functioning. My own career is a basket of sorts, and there have been 6 different phases of my professional career. One of them is actually being in fundamental research. The second one as a founder member of one of India's largest corporate R&D centers, namely the Research and Development Center for Iron and Steel. A third stage of my professional career was leading corporate planning, technology strategy, and business restructuring of SAIL, that is Steel Authority of India Limited. The next phase was engineering a turnaround and transformation of a heavily loss-making public sector unit, namely the Rourkela Steel Plant. I would also like to mention, subsequent to that, bringing and leading world's leading steel enterprise, bringing them to India, namely ArcelorMittal India Limited. And then finally, I would like to also speak a few words about being the voice of the Indian steel industry in the government and in international circuits. So I'll start with my tenure or my stint as a researcher in fundamental material sciences, or at that time we used to call it metallurgy. It started here in Bangalore at the Indian Institute of Science as an undergraduate student, and doing a research project with Professor K.P. Abraham, quite clearly one of the doyens of extractive metallurgy research in India and an educationist par excellence. I did work with him on the enthalpy and entropy of the formation of aluminum zinc alloys, which was an experimental work. I also would like to mention Professor Ramon Malia, who had just come back from University of Pittsburgh and introduced me to the subject of metal physics by asking me to give a seminar on the Bardeen-Cooper-Stryfer theory of superconductivity. And I think that prompted me to go into metal physics at the University of Illinois at Urbana-Champaign, where I worked with Professor Paul Beck, one of the founding fathers of the modern field of material science and engineering, along with Maurice Cohen, Alan Cottrell, and people like that. My work was actually more in terms of physics rather than metallurgy. I worked on low temperature magnetic phenomena of transition metal alloys. My measurements at and below liquid helium temperatures, which was quite rare those days for metallurgists to dabble in, resulted in the discovery of magnetic clusters in dilute spin glass systems and the occurrence of atomic short range order. You couldn't measure atomic short range order through X-ray diffraction those days. And this technique that I use, using high field magnetic fields, permitted us to look at atomic short range order in dilute alloys. This work was in collaboration with Dr. Simon Foner at the Massachusetts Institute of Technology, who was the inventor of the vibrating sample magnetometer and was a senior scientist with the National Magnet Laboratory. I think this work I did at Urbana-Champaign with Paul Beck, I feel that it was a small contribution to the new field of the development of material science. My next stage of fundamental research, or next phase of fundamental research, was at the Aachen Technical University, where I was an Alexander Humboldt Fellow. In fact, I was told by Peter Hazen, the chairman of the selection committee, that I was the first person from industry to be awarded the Alexander von Humboldt Fellowship. Here I collaborated with Kurt Lucke, one of the very eminent personalities in the field of physical metallurgy and metal physics in all of Europe. And this institute that he was the director of, called the Institute for Allgemeine Kunde und Metal Physics, actually was called the FCC Institute because most of the work they did that far, all the work they did that far, was on face-centered cubic metals. And I was interested in working on body-centered cubic metals, namely the steel. And the steel I wanted to work on was the enigmatic grain-oriented silicon steel, which is used in transformers and also in large generators. So he was quite supportive, I must say, that I should initiate a new direction of research in the institute. And we were very successful because what we did is, I used the new technique of what's called the orientation distribution function technique, and which is a crystallographic technique. And this technique, the use of this technique in body-centered cubic metals resulted in demonstrating a complete 1-1-1 fiber axis in steels, and also it resulted in the discovery of the texture memory effect in steels. I think the ODF work that I did at Aachen is a pioneering work in the use of ODF technique to the full extent. People had used ODF technique partially to generate, but I was able to generate the whole crystallographic texture in 3 dimensions. My continued fundamental work in bits and parts also involved collaborations with Professor Tony Diardo at the University of Pittsburgh as a National Science Foundation visiting scholar in the 90s, and also collaborative work on ultra high strength steels with Professor Warren Garrison Jr. at the Carnegie Mellon University, and with Dr. Bhakta Rath at the Naval Research Laboratory in Washington. In 1973, I was invited as a founder member of the upcoming Research and Development Center for Iron and Steel at Ranchi. This was a unit of at that time it was called Hindustan Steel Limited, and which later on became the Steel Authority of India Limited. I think this was a challenge for me because it involved the use of basic sciences, fundamental sciences, into the development of new alloy or new steel products. I'll mention a few of them. This also involved research into process metallurgy. And I think I feel satisfied that we were able to develop new processes in the sense of the Indian context and new products without any technology transfer. I'll mention a few. One was the continuous casting of electrical steels, continuous casting of weather-resistant steels, continuous casting of microalloyed steels, and continuous casting of line pipe steels. In the 70s, continuous casting was not so widespread as it is today. So these were new innovations using the facilities that were already available. In the context of development products, I can mention the LPG cylinder grade steel, for which I hold a patent. That's the steel that is used for our domestic cooking gas cylinders. Also, development of cold rolled non-oriented steels for motors and generators, high strength steels for structures and transmission towers, weather resistant steels for Indian Railways wagons and coaches, for which also I hold a patent, API grade steels for gas and oil and water transport, tractor discs, steels for missile launch pad, which I did for my group, and we did for Dr. Abdul Kalam when he was the director of the DRDL at Hyderabad. These works that we did at Ranchi, we were able to generate thousands of crores of revenues. I mean, it sounds quite a large number, but it is so, for the company over a period of say 10 years. And during this period also, I was very keen to collaborate with academic institutions. So we had collaborations with IIT Madras, IIT Bombay, Banaras Hindu University, and the B College, which is university now. My next phase of activity, my next stage of my career was leading corporate planning, technology plan strategy, and business restructuring of SAIL, the parent company, at the corporate headquarters in New Delhi. At this time, which was the late 90s, SAIL was on a decline. It was a Maharatna company Navaratna company at that time. I mean, at that time there were only Navaratna companies. It was on a decline and on a mode of making very huge losses. So we prepared a plan, my group prepared a plan, my division prepared a plan, which was approved by the Cabinet of the Government of India for the restructuring of SAIL, what we used to call the business restructuring of SAIL, which actually comprised a total overhauling of the operational modes, the marketing modes, and the raw material resourcing modes. I was the head of the Office of Business Restructuring at this point of time, and this work is contained in a large chapter written by the chairman of that time, Mr. Arvind Pandey, which was published in 2021, a book called Making the Elephant Dance. The whole restructuring work that I was leading, it finds a big chapter in that book. At this time, I was also chairman of Sales Task Force for creating a digital platform, one of the first in India, in fact, for the industries. It was the largest steel auction platform in the world. It became in time. It was called metaljunction.com, and later on, it's now called mjunction.com. It is in collaboration with Tata Steel. I think the biggest challenge of my professional life came about when I was posted. I was drafted, I may say, as the managing director of Rourkela Steel Plant, which was making 3 crore loss a day. Here my challenge was not only to revamp the technological framework of Rourkela Steel Plant, but also to change the work culture, which was, I think, an equally great challenge or even a greater challenge. And I used here a concept which I developed in the 1990s called the concept of the distance between minds. the distance between minds of people. This was a concept that I developed in 1990s and presented in many management schools. And I led what is called what I call the Sanskar movement, which was a reform movement to bring a change in the work culture, in the mindset of the people, for which I introduced what is now called in management literature as the mass contact exercise, which comprised sitting with 500 workmen every week for 3 hours without any break, and discussing with them, interacting with them, discussing with them, eliciting from them a commitment that we need to change the work culture, we need to work towards the survival of the steel plant, and then the revival of the steel plant, and then the operational excellence of the steel plant. And this went on for 3 years, and we were able to engineer a dramatic turnaround in these 3 years from 3 crore loss a day to 3 crore profit a day. This work at Rourkela is features in many management journals and management books, and some even have called this mass contact exercise as a communication revolution, a unique exercise in the corporate world. The next phase of my professional activities were actually with an international steel company, the largest international steel company called ArcelorMittal, and I was instrumental in bringing them to India and establish ArcelorMittal India Limited, a pan-India steel enterprise. I also was instrumental in setting up the ArcelorMittal Design and Engineering Center as a global facility for the company, that is ArcelorMittal. I spent about 7 years with them, and then the government, the Secretary of Steel actually asked me to lead what is now called the Indian Steel Association, which was formed at his suggestion to be the spokesperson of the steel industry as a whole. And the membership comprised not only the public sector steel companies, but also the private sector steel companies. So this was actually 2014 to 2017 is one of the most critical periods in the, if I can put the, I can use the word, life of the Indian steel industry. Because of what I coined as the predatory pricing of the steel companies in China, Japan, and South Korea. And because of the Indian Steel Association's interactions with the government, we were able to convince the government to take measures to protect the steel industry, but also my idea was also to push the steel industry to improve their operational efficiency. So this was a very successful 3-year period for the Indian steel industry, and the Indian steel industry bounced back as one of the most important steel industries in the world. Today, India is the second largest steel producer in the world, and also India is also the second largest steel consumer in the world. I recall that when I joined the steel industry in 1973, it produced a meager 5 million tons of steel. Last year, it produced about close to 149 million tons steel, which is like a 30-fold increase in steel production. In my career of more than 50 years, I have a sense of satisfaction of contributing to this phenomenal growth. I have a few concluding remarks to make. I often wonder what is the future of engineering, particularly in relationship to our own country, our own nation. Of course, we think that engineering and technology, they bring cost reduction, they bring increase in productivity, they develop new processes, and they contribute to the development of new products. We now have many advancements which are like quantum leaps, like the use of artificial intelligence and machine learning, the use of AI-enabled robots. But at the same time, we should not overlook what I call the negative implications, the negative impacts of technology and engineering. A major concern, I think, for the society at large is what technology is bringing in as a cost to life and living. And of course, you know that the advent of AI will mean creating large data centers and a lot of consumption of energy. A philosophical question also comes to your mind. Why engineering? Why is its value? If you look at it in a historical perspective of last, say, 10,000 years, I have an idea that I would like to share with you. I invoke the Rig Veda here. My understanding of the term dharma, dharman, in the Rig Veda, is that dharma is responsibility. It has undergone many changes, of course, many new forms like devotion, duty, etc. But in my mind, I follow the Rig Veda. Dharma means responsibility. And responsibility to whom? Responsibility in bringing sustainable prosperity, responsibility to society, to the nation, and to humanity as a whole. And engineering and technology should therefore bring sustenance. It's their responsibility of engineers and technologists to bring sustainable prosperity, balance between technological advancements, economic progress, balance between human beings, animals, and nature. Now I go back to the title of my lecture, which is not here, but I had given a title called The Journey of a Matchstick in Pursuit of Light. Now I'd like to explain this in a couple of minutes and why I use this title. I always thought of myself as a little matchstick, pursuing light and seeking to light the lamps, some lamps of knowledge. I feel that the INAE fellows, the esteemed INAE fellows who are here, who are also not here, is the cream of India in a true sense. The next generation of INAE fellows would contribute, would accomplish much more than the generation of INAE fellows, my generation of INAE fellows. India's 1947 mission of Vikshit Bharat is a challenge and opportunity for the fellows of INAE and INAE as a whole. I am sure that the contributions of the fellows of INAE in future will be monumental. They will light up millions of lamps of knowledge. They will light up India as a nation. And I fervently hope that they will be the world's leader of knowledge, intellect, innovation, and creativity. Thank you, and my best regards and best wishes to all of you.
Our second lifetime contribution awardee is Professor J.B. Joshi. Professor Joshi is the Chancellor and former Director of Institute of Chemical Technology, Mumbai. He is a very renowned chemical engineer, and he has done outstanding work in the development, design procedures, and for multi-phase reactors, which form the heart of chemical processes and nuclear industry. A unique blend of theory, modeling, and experimentation, it has resulted in the rational basis for the design and scale-up of large number of commercial-sized reactors in India and also throughout the world. He has been able to enhance the productivity and selectivity for a number of ongoing manufacturing processes, including those competitive offers and global basis. He has invented a large number of novel designs which are far superior in performance and less expensive in capital and operating costs, and these have found even in the export market. Professor Joshi.
President Mr. Patil, Chairman Dr. Goel, other distinguished fellows on the dais, in front of the dais, the fellows and dear friends. First of all, I express my sincere gratitude to INAE for conferring this prestigious award to me. I dedicate it to my institute and my teacher, Professor M.M. Sharma. In my institute, there are already 50 Lifetime Achievement Award winners. So you must realize that why I am paying respects to my institute. And then the credit also goes to my wife. As we have become older, we travel together and try to solve all family and societal problems together. The title is Generation of National Wealth through Science and Technology. So increase in national wealth has been my lifetime motto. Actual motto is to prepare the next generation. I have guided about 134 PhD students. The real motto is prepare the next generation for identifying problems of our nation. Find the clear objectives, the methodology to solve the problems, the money required, and whether solution of the problem will generate great wealth for our nation. I am going to give you just 2-3 examples, and there are at least 50 examples where big technologies have been generated and implemented in the society. It is wealth generation for our nation. All of us know that on the basis of per capita income, India is in bottom 20%. I am not saying bottom 11%, bottom 20%. Why? The income of any country, the major two sources, at least as far as India is concerned, is industry and agriculture. Industry, we are participating only 1% in the international market. 1%. If we try to find simple answer to this, the cost of production on an average, I am simplifying the problem, the cost of production is about 15%, 15% higher than average of the international market, and therefore our Indian companies are also not buying Indian products. They prefer to buy from other countries. The second, agriculture, I think I have a slide, next slide. But if you take any sector, any crop, rice, wheat, and many others, corn, our productivity per hectare is 2 times less, many times 3 times less, many times 20 times less. Tomatoes we grow per hectare 20 times less. What I was saying was, our nation is poor in bottom 20% mainly because of the income, and major income comes from industry, which is 1% contributing, and agriculture, which is not competitive. So I have selected 2 or 3 examples in order to address these issues. Can we not be 15% lower than average cost of production of the world? Can we devise some new products which are new and novel and find new markets, or make them so economical that the market is ready? Next slide. So here there are rice, wheat, mangoes, sugarcane. In bananas we are 2 times less. In tomatoes we are 18 times less. So at least 2 times less, many times 3 times less. Next slide. Next slide, please. Having less income from the major 2 resources, we import many things, which is of the order of 35 to 40% of our income. The major one is crude oil. 18 lakh crores, electrical machinery 7 lakh crores, and so on. So the total is 60 lakh crores. This much we buy. Our income is less, but we buy. Next slide. This is a stark example. In case of titanium, the total reserves of ores in the world are 600 million tons. And India itself is having 100 million tons. It used to have 100 million tons. When tsunami occurred, the tsunami added lot of sand on eastern coast, and we now have a raw material which is sufficient for 500 years for the entire world. This is the starting point. But we don't have technology. We sell that sand at 6 rupees a kilogram and buy titanium at 2,500 rupees per kilogram. This is the present situation. Next slide. So, I mentioned that I am going to give you 2-3 examples. A product where cost is 15% higher as compared to world, how we have brought it down. So, the first example I am giving is manufacture of hydrogen peroxide. Next slide. I have simplified the reaction. Ethyl naphthalene. Naphthalene means 2 benzene rings and then ethyl group. When it is hydrogenated, 1 ring is hydrogenated and second ring is not hydrogenated, it is called B. And when both the rings are hydrogenated, it is called C. The product B, when it is oxidized, we get hydrogen peroxide and back ethyl naphthalene. But if you go to C, then it is a solid product. It interferes with the continuous operation and it cannot be brought back. And that really is responsible for increasing the cost. The 3-step procedure for reducing cost is insight. Whether we have understood the chemistry and engineering principles behind that manufacture, that is insight. That gives us innovation. Then we implement it. If required, we use artificial intelligence and then the optimization. So see this. When we studied this in the laboratory, A going to B was mass transfer controlled and B going to C was reaction controlled. That is, if the dissolved hydrogen in the liquid is 0, B going to C will never occur. It will not occur. A going to B will occur at small values of mass transfer coefficient as compared to chemical reaction, and then A going to B will control. So in the actual reactor, which is a next slide, which is a vertical cylindrical vessel, the hydrogen is sparged, is introduced from the bottom, and hydrogen bubbles, they rise. While they rise, the hydrogen dissolves, and hydrogen dissolution is called mass transfer. And then unreacted hydrogen goes at the top, is recycled, and there is a recycle compressor. The catalyst required for hydrogenation is suspended because of the turbulence and dispersion generated by the hydrogen. So the dispersion, as expected, it increases with the velocity of hydrogen. Right? So at low velocity, most of the catalyst is in the bottom region, remaining reactor is not utilized, and that adds to the cost. And if gas velocity is increased, for increasing suspension of catalyst particles, then mass transfer coefficient increases and B going to C occurs. So at low gas velocity, the problem is of suspending catalyst. At high gas velocity, there is a problem of B going to C. Now this we call as an insight. So the next step is, next slide. As an innovation, we have connected a parallel pipe, a parallel vertical pipe to the main column. In the main column, there is gas, liquid, solid dispersion. And we know that hydrogen gas density or any gas density is negligible as compared to liquid density. So out of gas, liquid, solid dispersion, the overall average density here, and when hydrogen goes up, it is separated from the slurry and we get only slurry here. So average density here, because gas is not there, average density here above this point is less, and therefore static pressure here is less than the static pressure here. We get pressure driving force and liquid starts flowing, goes up, takes a turn at the top, returns, and we generate liquid circulation. If we adjust the liquid circulation equivalent to settling of solid particles, particles suspend on their own. I repeat, the job of gas, which was doing the job of suspending catalyst particles, has been withdrawn and it is given to the liquid circulation. And we adjust the liquid circulation velocity in such a way that particles are suspended everywhere in the reactor and we make the entire reactor effective. Having made reactor effective, now there is a choice of having gas velocity. So we kept the gas velocity on the lower side, made the mass transfer coefficient much less than the reaction. B going to C was eliminated, A going to B was happening, B going to oxidation, and hydrogen peroxide. When the problem was mentioned to us, there was 70% conversion, raw material 70% was getting converted, and the selectivity to B was again 70%. As we implemented in the plant, the 70% conversion became 80%, selectivity became 80%, and whatever insight we developed, we explained to industry people, and industry people are wise at least. And they took 70% to 80% to 90% to 100%, and selectivity also from 80%, 90%. So from that point onwards, the plant is working with 100% conversion and 100% selectivity. Cost came down, definitely 15% less than the international price. Next slide. I am giving another example of synthesis of carbon nanotubes. I myself wanted carbon nanotubes for my research. Therefore, and nobody was making in India. Therefore, I started asking the international producers. I asked the US company, they quoted $10 a gram. That is 9,000 rupees, 900 rupees per gram. China is cheaper, they quoted $10, and $10 is multiplied by 80 or 90 is 900 rupees a gram. $10 a gram and $50 a gram, this was the quotation. I had money to buy any amount from any country. There was no problem. But my blood boiled. This is not on. This is not on. And of course, most of the research, because my principal objective of life is prepare the new generation. So the new generation, so 95% of the work, I think it has been done by students. So they developed the technology. The insight was, while making it, it has to be plug flow. And there are many resistances in series. And cracking of methane, making it carbon and hydrogen, absorbing it by catalyst, and desorbing in the form of carbon nanotubes was the rate controlling. That rate of controlling step we gave an obvious, I am repeating again, that insight of the problem is most important, and give any problem we can reduce the cost. So the cost of manufacture became 3 rupees a gram. $50 multiplied by anything, multiply by 90, then it will be 4,000 rupees. $10, another 800, 900 rupees. We made it in laboratory 3 rupees a gram, 3 rupees a gram. And then it was very cost effective. The students, what they did further, with the help of those carbon nanotubes, they made a composite with high molecular weight ethylene. And that was so useful and important that you bullet AK-47, you direct at it, you will not even find out at what location it hit the composite. So this composite we made into bulletproof jacket. And several bullet, I must give a lot of credit to BRC because the work was done in the BRC premises, and the number of facilities that BRC has, almost you are in the heaven. You want anything, anything is there. Any expertise you want, expertise is there. Any book you want, everything is there. So we made bulletproof jackets. The chairman at that time, he was very resourceful, and director was also resourceful. He contacted the defense secretary. We have bulletproof jackets, will you try? And all the jackets by all defense laboratories and all police laboratories, 100% they were okay, all of them. And cost of production was 15,000 rupees and weighed 9 kilograms against imported 1,50,000 rupees, made 10% price, and it became most economical in the world. So our Honorable Prime Minister, he announced in the Parliament that as far as bulletproof jackets are concerned, we are spending about 2,000 crores per year for buying from, we shall not buy from outside, and next year onwards we will export. And Tata Advanced Materials Limited, which is here in Bangalore, then Midhani, that is Mishra Dhatu Nigam, that is government sector, each one started making 100,000 bulletproof jackets, and Bhukhanwala is the third company, they are making 50,000, and they have plans for making another 300,000, and we will start exporting. We are extending the technology for hydrogen storage, for catalysis, and for many other products. We have very good results for concrete, and the wind energy, those blades are normally 80 feet long, we have been able to make it 200 feet long. So at a given location, it will extract 4 times power as compared to present power. So that is about carbon nanotubes. Next slide. This is the reactor. The residence time is 2-3 seconds. The insight I can explain you, and I have published a lot of work. But the important thing was the catalyst should be a nanoparticle so that all the other resistances are eliminated. Mass transfer resistance, adsorption resistance, desorption resistance, cracking resistance, all were eliminated and the rates enhanced. Typically the residence time for making is 2-3 hours, and because of nanoparticle catalyst it came down to 2-3 seconds, and therefore the capacity, the productivity, and therefore the price, it came down. Next slide. So usual, the product we test against Raman spectra and ACM and TEM, and obviously we have to do that type of work. Next slide. And these are the jackets. Next slide. I am giving you another example. First example was just one case where we have been able to produce much less than the international price, and it is possible for any product. Now we have taken 13 problems, same title, reduce the cost of production, in such a way that it becomes competitive in the world. At least we will not. We have taken those 13 products where we are buying from outside worth 4,000 crores per year. And this at least will stop. If required, we'll start exporting. So the second example is agriculture, where I told you, emphasized you that the agricultural productivity per hectare is at least 2 times less, sometimes 4 times less and 20 times less. So how we address that problem? The biomass waste is about 4 to 5 times than whatever grains we get, or as compared to the useful product, the agricultural biomass is much more. This biomass, next slide. This biomass, if pyrolyzed, we get gas, liquid, solid products. Gas contains hydrogen, carbon monoxide, carbon dioxide. The liquid has properties similar to crude oil. I mentioned to you in one of the slides that we are buying crude from outside worth 20 lakh crores, and our own crude oil is not more than 5 to 10%. So huge money goes outside the country. The title of the lecture is Wealth Generation for Our Nation. And wealth is being generated by reducing the costs of agriculture, as well as here we are increasing productivity. The solids, which is a char, which can be support for the catalyst as an adsorbent and soil amendment. So for this crude oil, we joined hands with BPCL, and in their usual catalytic cracking, they added 5% and they got more gasoline. We are very happy. That is a premium product. They added 10%, even more. They added 15% and catalyst deactivated. So insight again. So raw material, if carbon by hydrogen ratio exceeds a certain limit, then we get deactivation of catalyst. So what we did, in waste plastic, H/C ratio is good. So we mixed waste plastic with waste biomass and did catalytic cracking. Again, problem was solved. It proved the principle that H/C ratio should be under the critical limit. The waste plastic is not sufficient to cater for the large scale cracking. The crude oil is much more. Therefore, we hydrogenated crude oil to critical H/C ratio and then did cracking, and it has solved the problem. What I am going to tell you again and repeat, this liquid that we get from 600 million tons of waste biomass is sufficient to replace major quantity of crude oil which we are importing from outside. 20 lakh crores of rupees, we can save much more than that. Next slide. That was about the liquid. The solid, if we analyze soil, and there is a soil of good productivity. Suppose for sugarcane it gives 60 tons per acre, and not so soil, unfertile soil is giving 40 tons. If we analyze, then if we take collaboration with the agricultural scientists, they tell that after comparing, the micronutrients are less. The right microorganisms are not there. Therefore, for the case of soybean, why soybean? As far as the rice, wheat is concerned, we are self-sufficient in all those cases. But as far as the oil, edible oil is concerned, we buy edible oil worth 1,50,000 crores. 1,50,000. Edible oil same as defense equipment. We buy defense equipment 1,50,000 crores. There we are not making also to the extent which is required. So what I was saying was there is an unfertile soil and there is a fertile soil, and when after analyzing both the soils, we know the difference between the two, and activate this char has a property of holding and releasing at a rate which we design, and it has a property of water holding capacity. So now the water requirement of the crops has reduced to half because there is a water holding capacity. So with this hot water holding capacity and ion exchange capacity, we tried to solve soybean problem, because we are buying the oil, edible oil. I thought, let me do this farmer's experiment in my own village. And many of my classmates are still there. Their next generation is farmers, but they are also farmers. And I collected about 100 people and gave lectures. And lectures were given also by the agricultural experts. We are buying 1,50,000 crore worth edible oil seeds. This I have said already. But oil seeds which are grown in India right now, if we increase productivity by 50% right there, we don't have to buy anything from outside. So the problem definition was very simple. So I went to village. I kept couple of persons there for guiding them. I took only 10 people, 10 farmers, because as we scientists, we don't scale up to a big thing. And now the soybean is ready, and there is a vibrant atmosphere in my village. They got increase in productivity by 50% to 400%. 50% to 400%. Now there is in my taluka and district. So I am going there this month end, stay there for quite some time, and now they want for sugarcane. It's okay, for us anything is okay. But we will not take many things at a time, so that the attention will get diverted. So again we will select now, instead of 10 farmers, we will select 30 farmers and slowly select it. Generate an atmosphere of positivity so that all the farmers, they will start, and the problem of 1,50,000 crores, that will be under control. It is done, it is successful on the large scale. So all the social workers and those NGOs, I am trying to connect them and whether this solution can be. Having done that, we engineers, we do a business plan. The business plan is like this. The basis is, previous slide. The basis is cluster of 5 villages. So what I have done from the internet, I know how many villages are there in India. And for 5, I made a grid where 5 villages are there. Average population of 5 villages is 25. So I know number of clusters, I know population of India, and therefore the population per cluster is also known. Land per cluster is 5,000 hectares, and we get agricultural waste right now 10 tons per hectare. Therefore waste will be 50,000 tons. I assume that since I am successful in soybean and sugarcane, let me assume that we can increase the productivity by 50%. Right? However, the requirement of India as far as rice, wheat and all these products are concerned, we are self-sufficient right now. So if I increase 50% productivity, there are no mouths in India to eat that extra 50%. Only oil seed problem is solved and the import is eliminated. So here, what I requested my dear farmers, you grow whatever rice and wheat only 2/3 of your land, 2/3 of your, and in the remaining 1/3 land, Maharashtra has a.
Professor, just few more minutes. Please try to conclude.
Few minutes I have.
Just
Yeah.
2-3 minutes you try to conclude.
Okay. So next. So here I have said that gas liquid product when I sell, next slide, I get some money, and then the capital cost of one pyrolyzer is 10 crores, the capital cost is 42 crores, depreciation and interest is there, operating cost is there, total cost I know, total income I know, and payout period is 3.1. The steel factory, they have requested me, if you give us a char, the blast furnace we will run on your char rather than the coke, and our steel will be called green steel. This is a benefit, but internationally there is now carbon penalty. So anyway we have to reduce carbon in our utilization. So I am emphasizing there is no business as attractive as this. 3 years payback period. Next slide. So if this is 5 village is implemented everywhere, then we get 40 million, 4 crore as job opportunities, extra 4 crore. We get 2,000 million metric tons of oil, much more than what we need in the society as India. That import we can stop. The title of the lecture is Wealth Generation for the Nation. Next slide. So before solving any problem, I go to industry and collect steel people, some other fertilizer people. What are your real problems? I try to understand them. Now here it was related to cook stove. So 20 housewives and 10 workshops I took. What are your problems? They told me, and when that problem was solved, you must have seen the chulha in villages. You get yellow flame 700 degrees, you get here blue flame 1300 degrees. Usual efficiency is 12%, here it is 62%. We sold about 5 million cook stoves. We also found whether they are really using or not, or whether they are facing any problem. Anyway, next. This is a problem. In our own one district of Maharashtra, 1 million cashew fruits are thrown, wasted, just wasted, worth 2,000 crores. The bioactives, the fruit has vitamin A, vitamin B, vitamin C, dietary fibers, then polyphenols. My students, they separated from each one. And one fruit, 1 kilo fruit, the raw material cost is about 3 rupees. And after separating these, if we sell all these products in the market, we get 100 rupees from 2 rupees. So because of the earlier problem and this problem, the per capita income of the villagers, and it is my desire and effort also, that all the benefits of these engineering and technology should go to the farmers and not to the industrialists.
Sir, can you wind up now? This concludes or something. Just
Next. So this is another source. Next. I made solar thermal much more cheaper than what National Academy of Engineering of USA said. Next slide. And the paper got published in Nature, and I have publications, and I got this award. This is possible, but wealth generation for the nation, that was most important. Next slide. I have an experience of 20 years for designing the nuclear reactors. And the new requirement is for 40,000 trillion hour, this much energy is required, and we are making right now 10,000, Vikasit Bharat. And we need 35 trillions of dollars as our wealth. Now, we have been told not to make present energy generation, electricity generation by coal. So that we subtract, then we will make only 4,000 trillion hours. We want 40,000 and nuclear plants. So making small and micro nuclear modular plants is a big project given to us. And recently our Honorable Prime Minister and entire Parliament has approved that this research can be done outside. We are collaborating with either L&T or Godrej or perhaps both and develop this further. Next slide. Anyway, what I say, I am working as a president of Marathi Vigyan Parishad, which develops scientific temper. If we want any field to be ripe and giving a lot of product, and if you are good scientists to solve the societal problem, then we make the society, the scientific temper of the society very good. Next slide. This titanium problem we have been able to solve, the red mud or ilmenite sand. First of all, we do smelting and we will make titanium at the cost of aluminium. Big statement. Next slide. So now time is not there, otherwise I would have explained what exactly is the insight and why people need more than 300, 400 rupees. Next slide. In 1947, we received political freedom. However, we are more than 90% dependent in terms of technologies and new knowledge. We have 19 refineries in the country. If you want 20th refinery, we ask for technologies from outside. Are we independent nation? And like this in pharma, no new pharma product is made in India. There are small exceptions here and there, but nothing more. We need to begin with yet another freedom fight for our own abundant knowledge, innovations and wealth. I have just 2 sentences to say. Our own filmmaker Satyajit Ray, he made one film, and that film was Shatranj Ke Khiladi. You might have seen, there was an invasion of Britishers to Lucknow, and there were 2 kings playing Shatranj. They did not even realize, these kings, that Britishers are coming and they are conquering, and they are complacent, so complacent, and they were entertaining themselves by Shatranj. So I made myself introspect every 4th Saturday of the month. Have we become complacent? Why the nation is poor? Why per capita income is in bottom 20%? Why there are 30% people below the poverty line? Thank you so much.
We go next, INAE Award, Professor S.N. Mitra Memorial Award, and I invite Professor Bhim Singh. Professor Bhim Singh, he's a ANRF National Science Chair and Emeritus Professor at Department of Electrical Engineering, University of Delhi, and internationally acclaimed electrical engineer. He's a lot of contributions in power electronics, electromobility, renewable energy systems. He has supervised 151 PhD students, which is the highest number anywhere in the world in area of engineering and technology. Under his mentorship, several startups have emerged, contributing to Make in India, employment generation, and technology self-reliance. With a large number of research papers, patents completed, sponsored research, consultancy projects, keynote addresses, he is a very well known person, and he stands out as for his blending of cutting edge technology innovations, nation building, social impact, self-service to education. Professor Bhim Singh.
Professor Dr. Goel, Professor Sanak Misra, Professor Joshi, my other distinguished awardee today, present president, past president, and distinguished fellows of academy, and my dear some of the young colleagues. It's a privilege. I am really happy to for conferring the INAE to this award to me, and it's a great opportunity that I can speak something about, typically about some of my thoughts in front of. Exactly, I didn't put completely that what really I have done past. So first I would like to certainly dedicate this award to my parents who never gone to school. I mean, they have been the typically farmer family. I mean, they have not seen the school how they have been, but I have really got inspired from them. I like to thank certainly to my professors who has been my master and doctorate supervisor, Professor C.S. Jha, who has been one of the founder member for INAE. He used to talk to me when we sit together, and Professor S.S. Murthy, who is here, and Professor B.P. Singh. So I was the first guy, I think, and PhD student in IIT Delhi to get 3 supervisors. Otherwise, normally it is 1 or 2, I mean, like typically. But in spite of getting probably, I was very fond after my graduation from Roorkee to come to IIT Delhi as a master student. And one of that time hobby was to get the job. So after even getting the 25 jobs, like a central government job, 3 times of engineering services and other jobs, state government, public sectors, my supervisor able to convince me why don't go higher studies, but of course they were knowing probably it will be difficult, so I joined as a project and then continued for the PhD and this journey. And I really very happy to come into the profession of engineering education, considering that probably even in being a government sector, I'm able to get around 15 years more compared to my other friends who have been in engineering profession. Like, of course, in academics we have a 5 year more. Then I got this NRF National Science Chair for 5 years, and next 5 years is also booked for through NRF Prime Minister Professorship. Is already I have to start from probably next year, like for next 5 years. So government is really, I really thank to the government also that they are considering to take me to up to age of 75. Certainly I have to perform. I'd like to thank certainly to my student, especially the PhD and master student, really they work hard. Of course, I have to grill them like anything, including at the moment. I mean, Dr. Goel already mentioned, and of course, it's mentioned here 151, but 30 still are roaming around. Since I have to go next 5 years, so I have to plan to about 60 more PhD students. Like that have been probably the lesson. That's about how it goes in the future. Apart from that, probably as a hobby, after the supernation in year 2020, I thought it as a hobby, as a mentoring the startup. So probably there have been many technology which work out, but within whatever technology we took in the last several years of research we planned, within 5 years we should be the number 1 in the world. It does not matter whatever the technology we take. Of course, my engineering discipline have been very conventional in nature. Obviously, it's a hardcore electrical engineering, not related to computer and other things. But of course, there have been a lot of opportunity in that also, and probably gone from electrical machine to power electronics, then drive, then probably power system, apart from that renewable energy like a solar energy, and then the new upcoming technology, which have been a very old technology called electric vehicle, I mean, like which is coming up. Like, so I will be talking about today probably a little bit about the electric vehicle, which I thought it, but after guiding around 15 PhD or student, around 10 PhD students are working in that direction. So I thought it, okay, probably research, I don't know whether how it will serve the purpose, but I thought it is starting some of the startup in the area which I am not really working, like typically lithium ion battery, then the BMS, then motors, then the chargers, and renewable integration into it, like also. So because time is limited, so I have to go also a little faster. And of course, I would like to thank my family, my wife, She dedicated, never disturbed to me, whatever, whether I want to work for 10 hours or 20 hours in a day or 50, around that. And I learned from the children, when I saw them at teenage age of class 11th and 12th working for 100 hours. I learned from that how to work for 100 hours in a week. Of course, they have been quite successful with the J15 and J12 and did AIMS only in, my daughter did medical in AIMS, so they have been very hardworking. I also really judge, they are able to do 100 hours per week at teenage age. Why I can't work at this age at the 100? I still feel, if I could have been my professor who used to say, Professor C.S. Jha, that the mind only work up to age of 40, I could have proved back similar to the 3-idiot dean that yes, you are the wrong. My mind start working after the age of 60 or 65 towards converting the technology towards the wealth, if we can do something in that or so. So with that, of course, have about on paper around 28 startups, but around 13 are successful, and probably every month one is added. Since my well-wishers and my friends says everything is 100, whether it is PhD or whether it is a patent, why cannot be startup also can be hundreds? So that's the journey of next 5 years. I thought it to do it in spite of next inning of the life. Of course, family is not disturbing me. They are cooperating in all the respect to me. And of course, I already mentioned that government is also very cooperative to give me a path for next 5 years. Otherwise, after age of 60, we start counting the day when we'll be going into the train of somewhere else. So coming to back towards quickly for this, what really, this electric vehicle, which really I chosen to work more prominently at the moment. If we look into the history, in 1996, the GM launched electric vehicle in Silicon Valley, and the company almost to become a bankrupt in couple of years because they have to withdraw all the vehicle. As it happens very recently with the Blue Smart, many of you might be knowing the taxi running in Delhi. Because of several reasons, reason I will not. But the technology which never develop, it never go to the waste. So it get converted to hybrid. One of my relative purchased the hybrid car, which runs with the petrol and of course with electric motors, and giving the average of 27 kilometers per liter, which usual car give around 8 to 9 kilometers per hour. So it means the energy requirement even for hybrid is around 1/3 what we have in normal car or automobile car like. Well, if you look into 2006, in the same Silicon Valley, the Elon Musk put the Tesla car, and I hope you know, in last probably 18 to 20 years, he is the richest person of the world. Very dangerous technology, but the required technology for the human being. The reason being 1/3 of the energy of the whole world, half the energy of the whole world goes to transport sector. And this is all your petroleum product. And if we are able to reduce, like I will talk about with some evidences, the energy requirement for electric vehicle is reduces to 1/6 to 1/10. If we reduce this requirement, and you can understand, if half the energy of ours goes to transport, and out of that, half energy we reduce to 1/6 requirement, I don't think we have to take the oil either from Russia or from America. So with the thought of that, I thought why not to work in this technology, how much we can contribute towards that also. Well, this is some of the benefits I mentioned. Most of you might be aware because it all the time in the media that you are able to, no new fuel, of course, very fast pickup around 60 miles means 90 kilometers in 2.5 seconds, which Tesla mentions it, and then cheaper to run. I already mentioned the energy consumption goes 1/6 to 1/10. I was probably delivering, just to mention a little bit, 2020, in the year which I was supernating, I couldn't believe how it have been miracle because of COVID. We have twice the COVID with my wife and myself because children are already in North America, and they try to keep every kind of precautions, putting every kind of appliances related to COVID in the home. And my wife asked to the phone, why you are wasting the money? They say, we can't come during the COVID, even something happened to you. So we want to protect in that. But what typically, this this becomes the typically cheaper. Why it is during that period in 2020, I delivered around 56 talk online, and one talk I was delivering on electric vehicle. I was not knowing who is listening. They were the mechanical engineers. They say at the end when there was a question answer, they say you captured our car. Your car is totally belong to mechanical engineering. So I have to answer no, we have not captured your car. We have only changed your engine of 30 to 35% efficiency to 95% of electric motor. And after that we recover the 50% energy back through regeneration. That reduces the consumption of energy to 1/6. Very straightforward. Now not doing any much innovation to it like also. But of course that year given me a really leap of 2020 where I have to graduated around 15 PhD students with 120 publications, reasonably top in IEEE transaction around 83 publications, 240 conferences and 15 PhD, and in spite of teaching the first year BTech course with 530 students. Like, I don't know from where the energy came. The reason being nobody was disturbing, because in academics what happens, everybody enters your room and it is undeterministic. And I consider, because of several reasons, I consider that profession not to so good, because you have to prepare the lecture in the night only on your personal cost. Okay, whether your wife want to sleep, your family want to sleep, but you have to prepare the lecture for the next day. I mean, but that probably time there was no disturbance for that. Sometimes it gave a really bad shape, but it was really miracle year for me. And that has changed. I'm not able to maintain, trying to maintain that year 2020 or so. Like, anyhow, that's coming to as a little bit blip. So these are the some other benefits of health benefits, like in Delhi we talk about now, odd even, and so many things there, but probably electric vehicle may really pacify a little bit about that one, like also. So energy security, other things, I mean, like, one of the major reasons have been the oil production. In 2010 it was balanced. How much was the production? Same was the use. But after 2010, the production of this petroleum start reducing and cost is, I mean, the requirement is gone increasing, typically majorly in the transport sector. I mean, we consider major consumption in transport sector only. So how it can be the gap? Either you look into alternative technology, I mean, or people start using less, and using less is not really the answer. I mean, so you have to look alternate technology, and that's the another reason forces the people to think about probably for electric vehicle, which I feel. The another technology which renewable in last 15 years I work out with the solar. We work out the solar. We are number one in the world in the solar as far as the deployment is concerned, working in the area of power electronics. I mean, why? I mean, typically, I mean, in year 2000, I took a delegation to UK, and I mean, we are supposed to plan, certainly work on this energy. I told, you are putting lot of money, probably, I don't know how many hundreds of crore government of India put to develop solar cell, and efficiency with not more than 20-25% like order of that. I told some money you put for utilizing and as an engineering role of this, like, so we start working on typically the solar. But that's a different apart. At the moment, I'm not talking too much. Like, I might have guided around 25 PhD in solar grid interface or solar power generation, and we work, especially to mention a little bit, we work with the Shakti pump around. They gave 1 crore in Staraviskar project, and they really gone to solar water pumping system, and probably the industry is number one in the country, and in the last 5 years, their stock have gone 49 times. That gives the evidence that really they developed something. I mean, like, and they started another industry in EV as well as in another industry in solar vapor to solar modules. I mean, they say we would like to develop everything related to that probably in our own country. That was the interesting. But you can just see how this energy, I mean, which is required, because electric vehicle you can run with the electrical energy you can produce by other means. And this is one of the way that you can get electricity generation from solar or wind. And solar you can see from 6.47 rupees, 6.5 rupee to it has gone 2 rupee in year 2020 or 21, when the panel cost was around 32 rupee per watt or 32,000 per kilowatt. Now the cost of panel is already gone less than half. If you go to the straight, really very standard panel, it's already 16 rupee per watt. And if really you go to raw, typically a grey market, which really flourishes around 50% in India, coming from neighboring country, it's around 10 rupee per watt. So if it is a 10 rupee per watt compared to 32 rupee per watt when it was the cost, I expect in next 5 years certainly it's supposed to be go to 1 rupee per unit. In Middle East it's already 1 rupee per unit. You know all the why Middle East put really lot of effort for, because they need a lot of energy for air conditioning or otherwise. I mean, we talk about all the country which really have a lot of oil even, and they are very sure somebody will take the oil by either you kill the Saddam or you do whatever war, nobody will leave the oil with you. But if you deploy the solar on your rooftop or anywhere for use, nobody will take probably that. So they start investing, and probably even Indian companies start also in oil company of India start also investing, many startup as well as in the solar generation like. So we expect in next 5 years this will become further half to 1 rupee. At the moment, I mean in central government in Delhi, purchase around 125 electric car and put to secretaries and additional secretary rank. And what it was put in the paper that those cars are running with the 80 paisa per kilometer as a fuel charges. If that is the 80 paisa with this, typically the energy produced like a 2 rupee by solar, if we reduce to 1 rupee per unit, we expect the car will run next 5 years maybe only 40 to 50 paisa per kilometer. That will go as usual if we are able to produce the energy at such low cost like.
Professor, next 5 minutes please.
Only 5 minutes left, okay. Okay, yeah, that will be more than enough too. Okay, so I can go a little faster. These are the technology, of course, concept and the classification, and you can think about only 215 watt two-wheelers. I mean, or I can say this will, that's a 250 watt two-wheeler can drive with the one unit of electricity, you know, how much? 65 kilometers. And who drive this? Your 50% population, girls and ladies. And of course, the speed limit is there 25 kilometers per hour. But it suits you very well, you know. Neither dupatta will fly nor the sari will fly. They have restrictions now. And they can drive the short distance to their office and all that. So it suits you very well for 50% population. Such a economic, like in 5 rupee you can drive a whole week of around 65 kilometers if you have short distance of travel like also. But you can think about, this is another vehicle. You know how much 82 kilowatt motors into it. Who drive it? Your teenagers, boys. And in the back, why you know such high power? Because if in the back, if somebody else is sitting, they will like to make it aeroplane. That's the requirement also of a reasonable population in the world to drive it. I think many industries coming up with this. Even a four-wheeler use only 81 kilowatt, but a two-wheeler use 82 kilowatt. This is the technology you can think about. I am just trying to probably mention it, how it really differ from one. And this is the technology for India. You know why these three-wheelers? It has given employment to 5 crore people at the moment. I mean the e-rickshaw, illiterate people employment, 5 crore, and every year 50 lakhs are added. If you add something into it, will it pay back a lot? I mean the more important, I feel important here, to create the employment people of uneducated masses like. This is one of the technology which really can provide employment generation, especially employment generation to uneducated masses also. So there are many activities which can be around this. I just put the photographs too typically. And Indians are so crazy, they start able to put solar panel to this. They clearly say 50% you can increase the range. From 90 kilometer you can run 130 kilometer in a single charge. It supplement that. Like I asked my student that it is so interesting to look into maximum power tracking of this solar, because now this e-rickshaw is going below the bridge or below the tree and suddenly it comes into sunlight or so. So putting the concept like, and just see typically the kind of activities, Nescafe soap on the too much children e-rickshaw, typically ice cream vendor can use it. So these are the activities, I mean the public themselves, illiterate people are bringing this technology into the use for the people to human beings, like I mean typically also. So that's now vegetable soap. So lot of variety. I put a lot of photograph in the sense, then these are the kind of activities go with this kind of three-wheeler of electric vehicle and also. This is another one you can think about how fast the Tesla has put. He claimed it does not matter the cost. I mean he is able to sell probably a car of 1 crore rupee. Lot of people are there in the world. Even India, if you float this, people will buy He will not be able to meet the requirement of so much, but the quality that you don't touch for 15 years this car. Even if you buy the petrol car, na, you have to send 4 times in a year for the service. But this car, he claimed, I mean the Tesla claimed, you 15 years you not to go to service or anywhere else. Like in his spite, it has a battery and everything. Like so, it's a question is that how reliable, I mean what quality of technology you put it. How the typically, I mean we talk about that. Okay, your combustion engine gives this kind of characteristic, and to match this, what we do, we put this gear. But electric motor, can do without any change of gear. But what we use it here, electric motors with very high speed. We have seen motorcycle at 5,000 RPM, e-rickshaw at 3,300 RPM. The tire runs at 300 RPM. We could have made the motor of 300 RPM. But if we go to 3,300 RPM, the size of the motor reduces to 1/10. If size reduces, volume reduces, cost reduces, losses reduces, weight reduces, all suits well, and we use the single stage gear 1 to 10 or 1 to 20 like also. So that's exactly too little mentioned to about it, okay. And of course people use initially induction motor. Tesla used induction motor because it was proven for 125 years, okay. But let the other fool prepare well another motor like permanent motors. Now 15 years that's developed, and Tesla also picked up quickly with if it is a better motor also. So coming out this, then another is the charging infrastructure. I mean this is the kind of classification, but you can think about a modest car have to use the 4 charger, fast charger, single phase charger, 3-phase charger, and wireless charger. I mean you are taking a so costly car, you will not have a patience to hook up the connectors. Na? You go to the home and put the car on the platform and it starts charging. The technology this is coming up as a wireless charging, to mention it. Just to mention it, Tesla have a wireless power transfer in 85 or 80, around 1900. After 125 years, MIT repeated the experiment of this wireless power transfer. Repeated the experiment. MIT is supposed to be a big for research, no? But they repeated the experiment of Tesla, and after 4 years, Nissan brought the product called wireless charging. Now 20 industries are manufacturing this wireless chargers, like because there is a demand, and every car, if you think about, if you have in India 100 crore car, 400 crore charger will be required for or so. So that's to come up. That's the fast. I like this slide that you can have a charging station, fast charging station. Why you can put wind, you can put solar, you can put the fuel cell, you can of course put the battery also for the power leveling to take from the grid, so that grid don't feel any exertion or so. Like people are crazy. Think about solar and wind together, and they claim that 2 lakhs to 34,000.
We can conclude now
unit
quickly,
it will
please.
give in 1 year. 1 minute I will take, and just coming up like, and then so much miles it will run also. Well, we have a technology called vehicle to grid to vehicle, and all the purpose it can serve around or so. And of course, there is a government of India put a mission, of course, to improve further on the motor part, and you have a lot of missions like rare earth material mission, semiconductor mission, which really support to this also. What we expect it, that we have a technical manpower development for postgraduate, undergraduate, and then publication, patent, products, and more important is the startup for the creating the job. And thank you.
Request Professor Srishendu Day to give his talk. Professor Day is from Department of Chemical Engineering, IIT Kharagpur. He is a well-known teacher for his courses in advanced mathematical treatment in chemical engineering, novel separation processes, and transport phenomena. His NPTEL lectures on these subjects are extremely popular in the country and also abroad. He has developed an advanced membrane separation laboratory and designed and fabricated a number of relevant equipment for research and for undergraduate laboratory students, etc. He has worked in cross-flow cells, batch fabrication cells, hollow fiber spinning units, electrical field enhanced filtration setups, etc. His work on arsenic and fluoride mitigation in rural areas, particularly in Assam region, led to awareness generation of capacity building among the stakeholders. Professor Day has written 9 books with his PhD students, and they are well accepted in academic circles. Professor Day.
Dr. Goel, Session Chair, Professor Joshi, other co-awardees, and present and past presidents of INAE. At the outset, I would like to express my gratitude to confer me this prestigious award that will definitely encourage and motivate me for doing, in my further teaching and research. So in this particular talk, I'm just covering a journey, how to, my experience from a metamorphosis from the researchers to the researcher entrepreneur. So my research is always being motivated by the following factors: to do translational research and to develop a process, a product that would be useful to the society at low cost, efficient, having tremendous outreach capability without compromising the quality. The development of sustainable ecosystem so that the utility of the products are exploited commercially. So with this motivation, we started to develop some products. Of course, the timeline will be is anything around 10 to 15 years from the start of the research to the final product. So I'll be talking about some of the products that have been generated in my laboratory and commercialized. First one, the treated laterite for the arsenic removal. It's a natural soil, lateritic soil that is available naturally. So the closest competent to this particular material for the arsenic and the arsenic removal is the activated alumina, which is a synthetic material and therefore expensive. So we developed this material and did some chemical treatment and enhanced it arsenic removal capability several folds, and it's in granular size so that we can develop an absorption, packed bed adsorbent as a filter. So the typical capacity of this particular material is 46.5 milligram per gram for the total arsenic removal, and it is one of the highest among the granular materials that we have that is reported till now. So another striking feature of this material, it has a long life. The filter can be sustaining its performance till 5 years within a range of arsenic feed concentration anything around 100 to 500 microgram per liter, without regenerating during its lifetime, thereby reducing its operating cost extensively. And it does not interfere with the competing ions present, and it can work at a wide pH range. And this particular laboratory material has been developed in the laboratory first, then we scaled it up, and ultimately we came up with a reactor of capacity 500 kg per batch and installed it in one of the production facilities. This particular technology has been approved by the Arsenic Task Force, Government of West Bengal, as well as the Mashalkar Committee in Ministry of Central Ministry. So after that, this technology has been transferred for commercialization to 3 companies. The timeline goes like this: we started research in 2002. We got the DST funding in 2008 by showing the preliminary results, and then we deployed domestic filter and looked after its performance. And in 2011, we got a huge funding from UNICEF, and we deployed one community scale filter in one of the affected schools in one of the places in close to Calcutta, where the groundwater is contaminated with the arsenic. So then in 2016, we got 2015, we got the recommendation of Arsenic Task Force, Government of West Bengal, as a viable technology. And in 2016, the first technology transfer was taking place, followed by another 2 companies. So it is really took around 15 years effort to convert a technology that has been developed in the laboratory to bring it to the field. Currently, there are about 550 community scale filters deployed in various affected areas in West Bengal, Bihar, Jharkhand and Assam, catering to almost 7 lakh people. The community scale filters are having capacity 2 meter cube power, 5 meter cube power per hour capacity, and typically these are solar driven, running for 10 hours a day, generating around 10 to 50 meter cube of arsenic free water, catering to a cluster of villages. The next one I will be talking about the fluoride removal from the groundwater. Like the arsenic causes a skin cancer that is known as the arsenicosis. Fluoride causes a disease known as fluorosis. There are 2 types of fluorosis. One is the dental fluorosis, another is the skeletal fluorosis. It basically, in case of dental fluorosis, it weakens it spoils the enamel of the teeth, and deform the teeth. And in case of skeletal fluorosis, it weakens the bones and it causes the early onset of osteoporosis. So, therefore but the typical concentration in case of arsenic, it was 10 microgram per liter, but in case of fluoride, it is 1.5 milligram per liter. So there is a huge difference of order of magnitude, because fluoride is required to our body, required for our bones to some extent. Now, like arsenic, we tried to look into what is the source of contamination of the fluoride in the groundwater. We have found out that fluoride is always adsorbed to the rock in the form of the mineral phase is known as the hydroxyapatite. Then we tried to mimic the nature like arsenic, like the lateritic soil that we have used for the arsenic. We tried to develop the hydroxyapatite phase in the laboratory, and then we have found that the phase that has been developed, it is in the powder form, which is having a very high capacity for the fluoride adsorption. But this powder cannot be used as a typical media for the development of a filter, because that will require tremendous pressure drop and the leaching of the material. Okay, so therefore what we did, we used activated charcoal, commercially available activated charcoal, and then we tried to generate this hydroxyapatite phase in situ on the surface of the activated charcoal particles, granules, and inside the pores, and we were successful, and ultimately we got a adsorption capacity of the fluoride 105 milligram per gram, which is at least 7 to 8 times compared to activated alumina granules. So again, this particular technology was recommended by the Fluoride Task Force Government of West Bengal, and we have commercialized this technology to an entrepreneur, and currently around 35 such filters, community scale filters, have been deployed in the affected districts of West Bengal, Bankura, Purulia, and Birbhum districts, catering to around 50,000 people. Next, I will be talking about some of the membrane separation process. Actually, my research in water treatment has started with the membrane-based processes, and we have found out that whenever we are talking about some experimental setup, it is very expensive, and most of the setups that are available, they are basically we used to import from outside, like Sartorius, a German company, Vargov, it's another German company, GE Waters, US-based company. So these experimental setups were pretty expensive. So what we did, we tried to develop our own setups, and we found out our own design and our own fabricators, and came up with number of such setups. All of these are the laboratory scale setups which we are using as a product. And like I can give one example of this electric field enhanced ultrafiltration. In this particular setup, we can use the filtration of the charged macromolecules, and at the same time one can measure the zeta potential or surface potential of the membrane by applying an external electric field. So the cost of this particular setup is around 5 lakhs, and we can measure the zeta potential, and the commercially available instrument that is available for the measurement of the zeta potential is ZetaCat, that costs around 45 lakhs. So each of these instruments of the same identical specifications have been supplied by GE Waters to different laboratories, but each of these instrument was costing around in the range of 15 to 20 lakhs, whereas each of our instrument is we sell at between 4 to 5 lakhs with 3 times profit. The next one that is very important is the hollow fiber spinning unit. Like the flat sheet membranes, another configuration of the membrane is the hollow fiber. Hollow fibers are becoming very important nowadays, because one can pack large number of hollow fibers in a bigger tube, so that the filtration area will be maximum in a smaller volume. So therefore the design of the cartridge becomes very, very compact. So in case of hollow fibers, the principle of producing spinning of hollow fibers is very simple. It's basically an extrusion process with 2 coaxial needles placed, and in the annular space we send polymer solution by using the external pressure. And in the middle point, we send the water. Water being anti-solvent to the polymer. Whenever the polymer comes in contact with the water, the polymer gets solidified, forming the hollow core running along the length, and then the polymer thread is falling on a gelation bath that is also made of water. So the outer surface of the polymer gets solidified, forming a solid hollow fiber. And the typical internal diameter of such hollow fibers for water treatment are 500 to 600 micron, and the outer diameter is around 1200 micron. So these are thin fibers. So a typical hollow fiber spinning unit costs around 2.5 crores that we import from outside. One particular company in Bombay, it sells a hollow fiber spinning unit currently at the cost of 105 lakhs. So we developed our own, and the heart of the hollow fiber spinning unit is called a spinneret. That is basically the extruder. And every company nowadays, they are purchasing a Japanese spinneret which costs around 75,000 US dollar. We have developed our own spinneret. So these are typical spinneret, the tailor-made spinneret that we have with the stainless steel body and Teflon bush, and it can be used number of times. And then we have developed our own spinning unit, which is very user-friendly with all the specifications I have, and we can produce hollow fiber of different kinds. Like one can have microfiltration grade hollow fiber, one can get the ultrafiltration grade hollow fiber, nanofiltration grade hollow fiber, one can have mixed matrix hollow fibers, typically embedding various inorganic and organic particles like powder activated carbon, titanium dioxide. There are various other inorganics we can embed silicon dioxide, so that these hollow fibers will be having some special characterizations for typical adsorption towards the molar size solutes. So I'm having a video here of just 1 minute how to spin the hollow fibers. So here this is the spinneret that I was talking about. Then the hollow fiber is being spun, and it is going through the gelation bath, and then it is being wound in a spool, and the spool is moving translation wise so that the fibers are not being wound on the same spot. They will moving in the lateral direction like the bobbin in a sewing machine. So this particular unit we are selling at the cost of 15 lakhs, which will be at least 7 times less compared to any Indian product that has been available in the market. Each and every part of this machine is Indian. It is entirely an indigenous product. So with this bouquet of products, we set up a private limited company in 2012, incubated IIT Kharagpur, Technical Separation Private Limited. And till now we have, there are only 4 employees are there who are managing everything in the production unit of 1,000 square feet. And currently we have deployed domestic filters up to 2,000 liter per day capacity, around 50, and lab scale membrane separation setups. We have sold around 35 such units, and one was sold to outside to Cameroon. Our clients are Police Training Institute in Salwa, that is one of the military station near IIT Kharagpur. We have deployed our filters. The Women College in Mindapur, Ramakrishna Mission in Belghoria. There are 150 plus individuals in North 24 Parganas, Kolkata, Kharagpur, around Kharagpur and Mindapur area. The membrane units have been sold to various academic institutes and research institutes, including several IITs and NITs. So final takeaways from this exercise is that the nature is our greatest teacher, and we should try to mimic nature. If we really do something, then that will be the best way of solving a particular problem. You should think about simple operations with simple conditions like room temperature, ambient conditions like ambient pressure, so that the energy expense will be less. We should not use the non-scalable equipment like high-speed centrifuge, freeze dryer, etc., which cannot produce in mass scale product. We should not use the analytical grade chemicals. We should use the commercial grade chemicals, because analytical grade chemicals are always 5 to 6 times more expensive compared to the commercial grade chemicals. If we want to set up a production unit with the analytical grade chemicals, we can never be able to make a business out of it. We should check repeatability of the properties and the performance of the products with a solid scientific and statistical test. And of course, there needs a continued sustained effort. It is not that a particular PhD student has done on a particular topic and then he leaves and the project ends there. Next set of people should take it up and move it forward. And we should take, for any product or any process, we should take the approval from the regulatory bodies. Without their approval, no entrepreneur will come up for commercialization of the technology. We should not be frustrated dealing with the government officials, local authorities, common people, and infinite patience and positive attitude should be prevailed to bring a technology from the laboratory to the field scale. Thank you, sir.
Professor Kulkarni is a professor in the Department of Electrical Engineering at IIT Bombay. He served as a INA chair professor in the department and currently IEEE PS distinguished lecturer. He was editor of IEEE Transactions in Power Delivery. He worked at Compton Greaves Limited from 1990 to 2001 and specialized in the design and development of transformers up to 400 kV class. He received an INAE Young Engineer Award in 2000 and AICT Career Award for Young Teachers in 2001. He authored a book, Transforming Engineering Design Technology and Diagnostic, second edition, and received the IIT Bombay Research Dissemination Award in 1916 for the book. He also developed a virtual laboratory to effectively teach involved concepts in electrodynamics. He has more than 225 publications in reputed journals, conferences, organized several training programs on transformers and computational electromagnetics, and completed many industry consultation projects. Professor Kulkarni.
Distinguished attendees of this convention. First of all, at the outset, I would like to thank INAE for considering me work for this award. I'm really truly humbled. Since this award is on outstanding teacher, my talk will be on my contribution related to teaching and education only. So next. Green. So just a brief, my career. The highlight was initially I worked in industry for 11 years, and while working in industry I did PhD in external mode, and then after finishing PhD I joined IIT Bombay, and in 2000 I got INAE Young Engineer Award, and probably I was the first one from industry at that time to get INAE Young Engineer Award, since it was established in 1996, because that time I was working in industry. And then while working in industry, I was also key trainer to staff and workers in local language. So the teaching was inbuilt. I was sort of habituated to teaching, and naturally I then shifted to academics. So again, as I will restrict my contributions only to the education and teaching. So as was the 2 hours, the first 2 hours have already been mentioned in my introduction. I was also given a citation award by CPRI in 2014, and the fellow grade of IEEE was for my contribution to transformer engineering education. And of course I got fellow grade of INAE in 2012, mostly for my contribution in transformer education. So I published a book. This is the second edition in 2012. This has now 1500 citations, and this is referred worldwide, and it is a reference book for transformer industries globally. So initial part of my research at IIT Bombay when I joined was in coupled field transformers. That time it was a new, relatively a new field, wherein I developed codes for multi-physics simulations for various problems in transformers.
and wherein, as you can see in the slide, there is a coupling of various fields, and these kind of problems are there in every product, and this give me a lot of publications. Later on in last 10 years, primarily I moved to little bit of physics also, and worked on magnetic hysteresis and modeling of magnetic hysteresis in magnetic materials, and lot of complexities related to hysteresis phenomena in magnetic materials related to dynamic effects, harmonics, and anisotropy have been handled by my PhD students. I would restrict again my research papers which have high educational value. So some of the examples that I wanted to give was, since I initially for 11 years worked in industry, I knew the problems faced by industry people, particularly in understanding some of the phenomena that are observed during the design, during the testing, and at site. So after I joined IIT Bombay, I first tried to solve many of those problems, and such problems I am just listing now. One is half-ton effect, which was known by industry that such effect is there, but I tried to give a complete holistic explanation of the whole thing, and that was appreciated. Next is on eddy currents. My PhD in fact was on eddy currents, and then I continued to work on eddy currents and tried to basically publish papers in the areas wherein a lot of insight into eddy current phenomena are obtained by the researchers. Then I also worked on mechanical design aspects and improving the reliability of large transformers. In that respect, I analyzed the short circuit forces by using finite element method, as in this slide. Now the next contribution was in transient analysis, very high frequency transient voltage related to gas insulated substations. When there is switching in GIS substations, it affects equipment like transformers, and very high frequency transients are imposed on the transformer terminals. So you need a very advanced technique in terms of modeling these transients, and one such technique is multi-conductor transmission line, wherein each turn of a transformer or any electrical device can be modeled as a transmission line to capture high frequency transient phenomena effectively. And one example I would like to give in the area of testing, when transformers are tested, all three-phase transformers, typically there is a asymmetry in the losses measured between the phases, and the asymmetry can be very high, and for small distribution transformers one of the phases can read even negative. And for quite some time in industry this was really a puzzle. Although the total loss would come less than guaranteed value, but there was high skew. Again, that phenomenon I explained through clear formulation, and this paper is a copy of this paper is there in most of the test labs across India and abroad, and whenever such thing is observed they just refer to my paper. So now, having told my contributions as in the area of education, I would like to give some comments on today's educational field and the challenges thereof. So I would like to just give a anecdote of my journey of this thing, which started in third year of my engineering, and in it so happened that the topic taught by the instructor was very difficult, and students were making noise, and I was picked up by the instructor and told that I was told tomorrow you have to give the class. This was in third year engineering. It was a very difficult topic, but then I took that as a challenge, and next day morning I prepared and gave that lecture, and the students were not knowing, and they were surprised that how come I am giving a lecture. So that was the beginning of me as a teacher. As these are the summary of my contributions. One is, of course, I have told the book. Then I have done one NPTEL MOOC course, several invited talks, and I have arranged symposiums, particularly in the education area of education topics. I have also mentored many interns, and particularly I am very happy to share here that I have mentored many INAE interns in summer, as many as 7 teachers and 9 students in last about 7-8 years, and that has been very fruitful for my research areas. And yeah, these are some numbers. Many lectures I have been giving across engineering colleges and all that. I have developed 2 laboratories. One is in the area of high voltage, and one a virtual electromagnetics laboratory, wherein electromagnetics is considered as a very difficult to teach and understand subject. So I have tried to basically, through this laboratory, teach many difficult electromagnetics concepts through interactive mode and using applets. So next the last 2-3 slides only. So I just wanted to give some comments on today's educational landscape and role of we as teachers. So I see that what are the trends. The education field also is going to get little bit disrupted in coming years through various things. One is, of course, establishment of foreign university campuses. Students are inclined heavily towards IT, and there is a heavy skew, undesirable skew now between core and non-core engineering branches, which is not healthy. Student employability is issue. Retention of our own UG students for further studies is not so great. Exponential area increase in AI and its impact on jobs. And yeah, and the opportunities, of course, are there. NEP 2020 offers us a lot of solutions. I have seen in recent times, particularly in Western universities, they have started something like general engineering disciplines. So whether we should also do something like that, I would just put that thought in your mind. Because what is happening is today's, in the first year when students join, they have certain ambition to do graduation in a particular area, but they are forced to take in some other discipline. So this general engineering approach would give a lot of flexibility in addition to major, minor, degrees that are already established. Yeah. So. Yeah, we need to basically, I feel, reorient departments into various areas with specific research focus, rather than having especially electrical, mechanical, civil. So whether at least at some places we can reorient the departments in terms of the current research areas. So now I will be talking on mentoring of students and mentoring of early career faculty. So as I mentioned earlier, there is a heavy skew of students taking IT, and that is we need to mentor them and sort of excite them to take up, some of them to take a core engineering. There are language barriers and weak communication skills. Even in the IITs, there are problems, and we need to take care of that. Today's students, they are not able to manage time properly because of various digital things, and they get stressed. And basically, I have observed that we are, in order to de-stress, sometimes we actually are reducing the academic rigor, which is not desirable. There are uncertainty in placements. I think these mentoring aspects, I have already shared some of this. Since the time is little less, I will skip these points. So the last point I will like to stress upon, that I have found, observed in my career that IIT faculties are heavily, approached by, industries and for consultancy and all that. I feel that we need to really develop second tier and third tier institutes and their faculty so that the load of IIT faculty gets reduced and we get a good ecosystem. So, and to that extent, we need to really, the first and second tier IIT and other renowned colleges and their teachers, they need to really handhold some of the engineering colleges for, further improvement. So the last, aspect is faculty members. So I am talking of early career faculty members. What are their, say when they join, see in our times it was only like teaching and research. These were only two aspects that we needed to basically take care. But now we faculty members who join an institute, they have to they are expected to do many roles, and then basically how do we balance between these various roles is a question. In addition to this, balancing between roles, the publication pressure is too high. Added to that, there is a publish and perish syndrome, everybody knows, and added to that, this, proliferation of, online open access journals is there. And I have observed that many of our faculty members, IITs and other institutes, they are spending thousands of dollars per paper to basically get their papers published in open access journals, and this has to be handled at highest level through policy level, because the kind of foreign exchange we are losing is quite high. And in that same connection, I would like to suggest that we all faculty fraternity need to encourage our own Indian journals like Sadhana from ISC and INAE transactions. Just and to that extent, then we will try to solve this problem of open access. I think this is the last slide. I wanted to talk on effect of AI and ML on education and we faculty members. So yes, there are many issues we keep discussing about AI, particularly students taking advantage of AI for various reasons, and there are unethical practices. But this is now like mobiles and digital technology. This is like obvious, and we can't actually go away. We have to adapt and adopt AI, and we have to just see how we can use AI for betterment of our training and education. Only one example I will give. This last semester I took a course wherein I taught technical communication to students, and there were 250 MTech and PhD students. And then I needed to give them 250 topics, different topics for them to give seminar. So creating 250 different topics was almost impossible. When I asked ChatGPT to give that under 5 different specializations in electrical engineering, within no time it generated 250 topics, and all were almost distinct. So this is one example that I am giving, that there are certain advantages of AI, and we need to exploit, and we have to always, whatever work we do, we have to see whether we can use AI well to increase our productivity. I think this concluding remarks. I would like to acknowledge my mentors, teachers and students for all what I have been doing. Thank you.
We'll go to the next category of award, the INAE Women Engineering Award of the Year. I invite Dr. Geeta Manjunath. She is the founder of CEO and CTO of NIRA Health Analytics Private Limited, a startup which has pioneered in new non-invasive imaging tests for detecting early breast cancer. With extensive experience as a researcher at CDAC, Hewlett-Packard Labs, and Xerox Research, she envisages the benefit of using machine learning-based analysis over high resolution thermal scans for detecting abnormal tissue activity. She led her team to develop thermodynamics cancer screening test, which is now clinically proven to detect lesions in as small as 4 millimeter and regulatory approved in 20 plus countries. With this innovation, first time ever women can detect their cancer in privacy with no touch and no radiation. This affordable, accessible, and high-quality cancer screening test is creating a breakthrough in cancer care for developing countries. She won many international and national awards, including Women Entrepreneur for the year 2020 by Biospectrum India, and also she's on the Forbes top 30 Indian minds leading in AI resolution in 2024. Dr. Geeta Manjunath.
Thank you very much, and good evening, gentlemen, and few ladies in the crowd. So it's a real honor and privilege to be among the top lifetime of achievement engineers and others. Thanks once again for giving me this prestigious recognition of being Women Engineer of the Year award. Of course, it's over 30 years of career of different innovative technologies in Hewlett-Packard Labs. I was a principal scientist for 17 years. Then I was head of AI research lab at Xerox for many years. And I also initially started off my career at CDAC, Bengaluru, as one of the very young engineers being part of the first supercomputer being developed by India, which is Param and Paras. So yeah, over all of these years, and I've worked on 25 to 30 plus very, very interesting projects. But what I thought today is just spend one deep dive into one project, which is, just I'm spending day and night on it for the last few years, which Sir has benevolently given an introduction as well. We talked about, in the previous speaker talked about how AI is being used in education, and what I'm going to talk about is how AI can be used and is being used in the field of healthcare. This is a research that I started and quit my job and started as a startup 8 years ago, and it's been a wonderful journey. Just want to take you for the next 10 to 15 minutes into the deep dive of this so that all of you can take away something for you, for your family, wife, sister, aunt, mother, daughter, everybody. Okay, so we all know that artificial intelligence is being considered as a revolution in many fields, including in healthcare. And the first field that is primarily impacted with AI in healthcare is radiology, because radiology involves recognition of patterns in images, videos, etc. The X-rays, the medical images, we are talking about X-rays, CT, MRI. It's very, very hard to actually determine very, very small, minute variations, which may mean cancer, which may signify future cancer or current. Now, here, of course, there's several things that we talk about, how it can help, improve productivity, reduce misdiagnosis, calling out somebody as cancer when they don't have, as well as missing cancer, right? Both are considered as misdiagnosis, etc. But what I believe very, very deeply where AI should be used, after my PhD in AI from ISE and 20 plus years of working in the area of AI when it was not even as much hyped as it is today, I feel AI should really be used to bridge the gap between the healthcare divide that exists between the rural areas, urban areas, the haves and the have-nots right inside a city like Bangalore, or even the developing and the developed countries. It can be a huge boon to actually give this AI-based robotic doctor, if you will, to a rural healthcare worker to ensure that the right people, the high-risk people are identified at the right time and brought to the hospital, which is of course far, far away with a lot more infrastructure than what is there in the villages. So that's one main reason why I started NIRAMAI, to solve this one of the biggest problem in women's health, which is basically affecting 50% of the population in the world. 2,000 lives die every day because of this disease. Unfortunately, while breast cancer is completely curable, nobody needs to die of breast cancer. Every alternate lady detected with breast cancer is dying today within 2 to 5 years. This is completely solvable problem, I feel. Nobody needs to die of breast cancer. The only magic thing we need to do is, how can we enable all of them to detect it in stage 0, stage 1, as opposed to waiting for a huge lump before they come to a doctor. What that means is, by the time they feel the lump, it's already 2 centimeters or 2.5 centimeters, it is stage 3 or stage 4. Because of this reason, late stage detection having high mortality, we lose almost 50% of ladies today in many, many countries, definitely including India. In India, every 3 minutes, one person is detected with breast cancer. Every 6 minutes, we lose one person to breast cancer. This is true. I have the exact numbers, it's a WHO data. The reason is because nobody thinks that we should do annual screening like we do the glucose test, whatever. Nobody thinks we should do for cancer screening. Nobody thinks we should do for breast screening, right? That is the problem. We all feel, and everybody, all women, including myself, when I didn't know, because I quit my job because I lost 2 of my family members to breast cancer, and I said, I'm going to research in this area 8 years ago. And that's what, thankfully, with God's grace, here we are. But the screening rate in India alone is 1.3%. 98.7% of women are detecting their cancer by hand, whereas the same number in US is 75% or so. So this is what I want to change. How can we enable screening tests so that every lady in India can take the test? The problems further that we want to solve is accessibility, affordability. How can we make it cheaper so that every diagnostic center can provide a screening test? How can we make the resource needed to run that machine cheaper and less skill needed so that more and more women and girls or whoever, less educated people or healthcare workers themselves can actually use these devices and detect cancer? There are other issues like user experience, where nobody wants to remove clothes in front of others to do the test. That is another big, big barrier. Can we make it privacy aware? So several of these questions, in the interest of time, I just go into the solution. What we have developed is a completely new test for breast cancer detection, where we just measure the temperature variations on the chest using an infrared imaging device like the cameras that you see here, and convert the temperature map to a cancer health report using AI machine learning algorithms. With this, we've proven that we can detect 4 millimeter lesions, stage 0 by definition. And we do that without touching the patient, without seeing the person when she's not wearing clothes. It's such a primary requirement, but no other test in the world today can do this. No radiation, no X-rays, we just measure the temperature on the skin, which is basically infrared rays coming out of our body. It's just a passive sensor. And there is a huge limitation today that existing methods work only on women above 45 years, and 27% of cancer deaths are under 45 today. I lost my cousin sister who was just 38, and that's the reason why I started this. But yes, so many, 17-year-old I have seen with breast cancer, and this test does detect even in young women. It is 10% of the cost and 30% more accurate. And most importantly, it's very portable. You don't need to come to a hospital to do the test. You can take it out and do the screening outside. If horse doesn't come to the water, you need to take the water to the horse. I talked about no touch, no see. It's just like a photography session, and that's what happens. So let me quickly deep dive into what is the science behind it. It's definitely deep science. We have 39 patents in this. So everybody, most of you would know, but what is thermal imaging? It's just infrared imaging, which is one of the spectrums in the electromagnetic spectrum, right? So what we do is measure the temperature variations on the chest, essentially using an infrared imaging device, as I mentioned. We measure 4 lakh temperature points. So we take a click with a very high resolution infrared imaging device and get this temperature value of every 4 millimeters of the tissue. When there is cancer, there is higher multiplication of cell, there is higher blood flow, and so the area which is cancerous has higher temperature. But everything that is high temperature is not cancer. So how do we identify which high temperature is cancer? Secondly, if the cancer is very, very low, close to the chest wall, it doesn't even come to the skin. So can we map and create patterns of vascularity, feeder vessels, which are feeding to this blood flow? So essentially, we end up creating an algorithm or set of algorithms to detect very, very minute variations in temperature values and specialized algorithms to capture vascularity just using temperature values. So with this, we have been able to actually generate a report saying whether there's a malignancy or not, or whether there is an abnormality or not, red, yellow, green, what's the probability that it's malignant, and also giving a score so that you can even monitor over time, just like we monitor our blood glucose. Maybe we can change our lifestyle and literally prevent cancer. It is purely software as a medical device. We do not manufacture the infrared imaging device because there are so many companies who are manufacturing it. Thanks to COVID, there are more number of people who are manufacturing thermal imagers. So we measure the temperature variations, and the AI, a set of AI algorithms, convert that into a breast health report. There are multiple. First of all, I said I want to give this tool to the end users or even healthcare workers in the field. They make a lot of mistakes. Left go right, right go left, everything. So can AI make corrections when they actually make imaging errors? So we have a bunch of deep learning algorithms there. Can we extract the right kind of features? We have about 117 thermal features. These are called biomarkers, if you will, right? And also vascular patterns. And finally, we generate a report which can be read by a doctor. But you don't find doctors in a rural area. So for a rural area, we have a red, yellow, green automatically generated. By the time the lady comes out, the red, yellow, green is with a health worker. Whereas in a hospital setting, we actually give a detailed report. There are several machine learning algorithms, novel elements that have gone into it, right? To first of all, make the doctor see the image and abnormalities more clearly, as opposed to seeing a lot of red and yellow that you're seeing in the first image, etc. And I talked about vascular radiomics. I don't think you can see from far, but there are lots of vascular extraction algorithms that we do. Behind it, these are all the magical CNN models and VNet, UNet models that go in. We actually also take 5 views and convert a 3D reconstruction of it so that we can extract semantically meaningful features out of it. Multiple of them come together, and I have a few minutes. So essentially the report would look like a simple, like your blood report or an X-ray report or PET CT, automatically generated. There are about 25 different AI algorithms that work behind it. The scores, 3-4 scores that you see there, are the ones which tell, like if you want to monitor the health of a person post-surgery, or like she's high risk because her mother had cancer, you could do so, right? These scores indicate, like it's a probability score, 0 to 1 scores. As well as we came up with a final score called B-score, which radiologists understand because that's the scoring they use. So these are some what we call as explainable AI. In addition, automatically, the algorithm marks the likely area of malignancy so that follow-up diagnostic workup with an ultrasound or a mammo can be done. So it is a screening test. It is not a confirmatory diagnosis test. Once this one says it's high risk, then she needs to be brought to a hospital. The question is, does it work? So of course, that's why we took so much time to actually get into the field and do all the studies. We generated the sensitivity and specificity graphs by making people take our test, followed by mammogram, ultrasound, and biopsy if needed. And at the end of the prospective blinded study, we compute how many cancers did we miss and how many did we call out more. Sensitivity 100% means false negative is 0 in this particular, and many other studies we have done. False positives are about 8 to 10%, which is pretty much acceptable. And we have 56 plus publications in this, including Lancet Oncology. And even in young women, it's able to detect cancers which were missed by mammogram. And there are several, again, all of these are published literature, but I'm just sort of flashing it here. It is amenable to go to rural areas. We have done thousands of screenings in many of the rural areas in Maharashtra, Karnataka, Punjab, Assam, Meghalaya now, everywhere, Uttarakhand, so many places. One of our studies in Punjab, funded by the Punjab government, 15,000 women screened, 3% of them found to be positive. only those had to be brought. Of course, we're still struggling to get everybody to the next level. We already detected 27 cancer. It so happened that to get the same result or even lesser number of cancers, 52,000 people were screened in a previous study because they were screening with hand. So clearly, this is detecting 3 times more cancer than hand-based examination. So this is another proof. This is a Nature paper that already has received 3,000 plus hits in just less than a year. There are several other publications, which I don't want to go into each of these details, but unless you want to take it to the market, you can't make it really useful or create an impact. And I realized that unless we get a US FDA clearance, we can't use it in India. It's not by rule, it's just by mentality. US approved, then I can use. But okay, so we went ahead, got the US FDA approval. We also got the CE mark and of course the Indian clearance. But because of the CE and US, we got many more countries when we got the awards and all, they reached out to us, and I'm happy to share that now this Indian innovation is used in about 25 plus countries. But mainly it is used in India. More than about 4 lakh women have actually benefited from this test. We have detected thousands of cancers. Unfortunately, just 2 days ago, biopsy, yesterday she finished her surgery. She detected, she was already 70-year-old, still she didn't know that she had to go for a regular, but she detected with ours. Just within a week, her surgery is done. She's happily back home today morning. Like that, we've actually detected many, many more people. But like I said, people don't need to come to a hospital to do the test. We do screenings in corporate offices, we do screenings also in rural areas, and private screening at home. If any of your family members want to do, come to niramai.com, private screening at home. We'll send a girl home so that they'll do it in the privacy of your home. These are many of the countries who have adopted, including US, we have about 8 to 9 installations, but many other countries also have adopted. Many of the logos you can see, HCG, Polo, all of them have started. And also we do corporate camps. We go to an office, do the camp in the corporate office, and Google, Microsoft, everyone has screened. Here's the mobile medical unit. We go to the rural areas, to do the screening in private, where no one sees or touches the person. It's like a changing room. She goes behind, closes the curtain doors, etc., and only she's alone in front of the device. I'm very excited about this new project we are working on. How can we actually make this like a glucometer at home, selfie? And this is being trialed in Denmark and Germany at this point in time. It's very important to have explainable AI, and next time I have time, I'll explain this thing. But with all the, glamour that's happening around foundational model and so on, but there is real value to this as well. So we started working on foundational model. Can we use all the data, 1.5 million data that we have managed to collect, create a foundational thermal model, and make infrared imaging a first-class medical imaging into it? Not just for breast cancer, for several other cancers that are coming. I can't do it alone. I wanted to go into the depth here because I wanted to call out this wonderful, brilliant engineering community to come in and collaborate to see whether India can develop this excellent, non-invasive, medical imaging-based and AI-based technology for the world. Thank you so much for listening.
Last talk, which is remaining from the earlier talk, Jai Krishna Memorial Lecture by Professor Anil Kumar Bhaumik. Do we have him on the line? Professor Bhaumik, are you hearing us?
Yeah, I can. And good to see you, Dr. Goel, online.
Oh, very nice.
I have shared my screen. Can you see my screen?
Yeah, we can see your screen. Professor Anil K. Bhaumik, former professor of eminence at the Indian Institute of Technology, Kharagpur, and founder director of IIT Patna, is currently a faculty at the University of Houston, USA. He is internationally known for his outstanding and seminal contributions to the development of polymer nanocomposites, sustainable materials, thermoplastics, elastomers, industrial polymer compounds, failure and degradation of polymers, polymer modification and adhesion phenomena in the materials, engineering disciplines, as revealed from his numerous awards such as 2025 Excellence publications have been extensively cited in the literature. He is recognized for his innovation and development of rubber products of national importance and rubber industries in India. We invite you, Professor Bhaumik, for your talk.
Okay. Good evening, everyone. Good to see Dr. Goel after a long time, and I see Dr. Mishra sitting beside him. Thanks, everyone, and thanks, Dr. Goel, for giving an introductory note about me. I express my heartfelt thanks and gratitude to INAE, especially the jury members, for recognizing my work and selecting me for the INAE Professor Joy Krishna Memorial Award 2025. I'm grateful to Professor Kamoniya Chattopadhyay, Indian Institute of Science, Bangalore, for nominating me for the award, and Mr. J.D. Patel, President INAE, for the decision of the committee. I extend my heartfelt appreciation to my students whose dedication continuously helped me to achieve excellence, my employers, Indian Institute of Technology, Kharagpur, India for 35 years, and the University of Houston, USA for the last 6 years for their continuous support and cooperation. My mentors and colleagues and my research funding agencies, both government and private. My wife, Kumkum, my son, Oshmet, for their unwavering support and sacrifice have been my greatest source of strength. This afternoon, I'm going to talk first on some scientific and engineering principles I used in my work. And then I'm going to give you a few examples of a few innovations done by me. I've used mostly rubbers in my presentation here, materials whose glass transition temperature is lower than room temperature. Intermolecular forces are low and mainly amorphous in nature. I want to start with nanoscience and nanotechnology and polymer nanocomposites, which I started in 1992. In fact, nanoscience was known that time to chemists and physicists. Nanotechnology was not so well known, although in the rubber industry, we have been using carbon black and silica for about 80 years now. And polymers, nanocomposites certainly was a new field that time. And I'm probably the first person in the area of polymer nanocomposite to start making them and understanding the structure and properties. In this particular area, I have done synthesis of various types of nanofillers, clay, silica, zinc oxide, magnesium oxide, etc., etc. I have also spent a lot of time on modification of nanofillers, especially the graphene, carbon nanotube, etc. And then when I started the work, dispersion was really a problem. And so I spent a lot of time in understanding dispersion methodology of nanofillers in polymers. In fact, I worked on thermodynamics using chi parameter, for example, to understand the dispersion. I had come up with a theory later on, which tells you why nanofillers are reinforcing in polymers by using some swelling experiment. And finally, I had done work on polymer nanocomposites, synthesis, various methods of synthesizing them, characterizing them extensively, and I measured the properties. My team measured the properties. For example, mechanical properties, adhesion properties, barrier properties, thermal properties, swelling properties, lots of properties. And finally, their application in tire and non-tire industries. Initially, I got support from foreign companies, but later on, the Indian companies came forward and supported my venture. Some of the funding agencies are ExxonMobil USA, Goodyear Tire and Rubber Company USA, JK Tire India, Bridgestone Corporation Japan, Denka Corporation Japan, Sabic India, Lanxess Germany, BK Tire India, Builder Carbon, and of course DRDO, one of the earliest funding agencies in this venture. In fact, I have given some diagram here on the type of work that I had done. On the left-hand side, you will find this is the functionalized graphene and graphite, various types of modification of graphite and graphene. And then we synthesized a lot of new type of filler, which will be scientifically very interesting. Commercially may not be so interesting. And scientifically means, for example, I have made a graphene roof and nanotube as the filler. This type of filler, which structure is given here. Then various types of clay, modified clays. We studied dispersion, as I mentioned, understood why some fillers disperse better in a polymer and why some others don't, and then spend time on the properties and applications of these materials. I have made new materials in my life, and in fact, elastomers are interesting material, the prime area of my research. And elastomers, one of the problems, they are thermoset material. Like when you make a tire, you cannot put them back again in another application. And so my effort was to make elastomer as processable as plastic, but they should have the elastomeric properties. These are called thermoplastic elastomers. I made many of them and reported them in the literature. I made special polymer blends and also modified polymers or functional polymers for various applications. Since 1984, I've been doing this type of work. Some of the examples are given here: thermoplastic elastomeric blends from nylon 6 and acrylic rubber. Acrylic rubbers are dispersed into nylon, although acrylic rubber is present in a larger amount, sometimes to 70% compared to 30% of nylon, but still it is dispersed, and there is a technology for dispersing them in nylon to make thermoplastic elastomeric material. Later on, we have come up with nanostructured thermoplastic elastomers. That means we did the structure refining, make very small rubber particles inside the plastic matrix, and achieved interesting properties for this material. They are thermoplastic elastomers, but with very interesting properties. And in fact, we studied the interface and studied structure property relationship of these materials later. Some of the materials which are interesting I made from sponsorship of SAVIC, for example, using their own material, whatever they had in their store. We made typical, very interesting thermoplastic elastomers for them. I worked with Shell, modified their ACBS to generate useful properties, interesting properties. Sulfonated ACBS, for example, acrylated ACBS. My project was supported by HALS. We made polyether ester amides and studied the structure property relationship. We made our own thermoplastic elastomers from a lactone-lactide combination, which is shown next. And then we have also made thermoplastic elastomer by modifications. For example, one of the constituent of the chains, like here in this particular case, double bond, is modified, and then you get thermoplastic elastomers, elastomeric portion along with the crystalline portion, and then you make thermoplastic elastomer. And then finally, metallocene-based polyolefinic thermoplastic elastomers we made by modifying the polyolefinic elastomers and adding zinc acetate to make thermoplastic elastomers. I'm involved in recycling green technology and sustainable materials since 1986. In fact, you'll find a lot of my literature, a lot of my work in the literature on recycling. For example, rubber waste can be divided into cross-linked rubber waste, uncross-linked rubber waste, and both have been utilized effectively in my work. I'm interested in the green technology. Electron beam technology is one of them, and I'm going to tell you more details about that later. And then finally, we made sustainable material from lactone, from various other sources. One of the sources, for example, we are interested in is the tarpaulin, which has not been utilized very well in our literature. And we made we mimic natural rubber by using beta-methane, polymerized by emulsion polymerization. The technique is shown here. And then we made interesting structure, understood the structure property relationship and the polymerization mechanism by using DFT, density functional theory, as well as the different mechanistic steps in this particular polymer, monomer and polymer. Now, those are the science says that we have discussed in the literature, but there are other things which, for the paucity of time, I didn't tell you, but we had also gone deeper into various other types of materials in the literature. But one of the interest is also on the failure and degradation of polymers, the properties in details. And one property, such property is the failure and degradation of polymer, because I've been trained in that area for a long time. And in fact, if you look at the literature, you will find my theory also on the threshold fracture and threshold adhesion of elastomers, which are reported in various books at this moment. So you will find in the failure and degradation area, we are mostly interested how to prevent failure, what is the mechanism of failure, and what is the lifetime of a particular elastomer, and how can you improve the lifetime of these elastomers. So you can see on the left hand side that we have improved the lifetime by addition of nanoparticle, and also we are interested in understanding how degradation takes place, what is the process of degradation. And we have used molecular dynamic simulation in order to understand that. Understanding a particular polymer degradation in a Denka project, we have been able to deliver them a new type of polymer, which hopefully will be commercialized in future. I'm also interested in tear and wear of elastomers, and my basic research was mostly on correlating tear and wear with the basic properties of the elastomeric material. And I'm going to give you some flavor later on. I specialize on adhesion science and technology. In fact, this year I was awarded the highest award from the Adhesion Society in US. And my work was between addition between rubber to rubber, addition between rubber to metal, addition between rubber to plastic and surface engineering. For example, in an ExxonMobil project, we are interested to improve the adhesion between rubber to rubber of their new material that they marketed that time in the literature, which is shown here, is called BIMS. And we understood the structure, we understood the viscoelastic properties, we calculated the monomeric frictional coefficient, diffusion coefficient, and then we found using a particular technique, we have been able to improve the adhesion between rubber to rubber joints. We are interested also in rubber to metal, and we had a project with Tata Steel, and we are interested there in beadware to rubber adhesion, and we studied the mechanism of the rubber to metal adhesion in that same project. I have invested a lot of my time on surface engineering of various polymers, and you can see the literature for those papers. Now I'm going directly into the application and some of the innovation I did by understanding the properties of this material, and very interesting application. Usually the professors don't take up such project, but I did because I'm interested, and I'll tell you also why I did. And you will find that they're very interesting, successful application. First example, I'll give you 3 examples. I've done many, but I will give 3 examples. One of them is battle tank trackpad and rubber wheel. This is a typical schematic diagram of the MBT Arjun tank, and you will find that there are lots of rubber pads, and these rubber pads are like this, and you will find that there are 384 such rubber pads, and 7 plus 7, 14 rubber wheels, and those are developed by me in my lab, and then technology was translated by using 2 factories, and then finally the product was delivered. And if you are not familiar with the Arjun tank, this is the typical tank. You can see that.
When it comes to war, no weapon dominates the battlefield more than the main battle tank. Backed by superior firepower, protection, and mobility, these armored monsters often decide the fate of wars. From capturing land territories to creating havoc behind enemy lines, the tank is the most destructive war machine during any surface combat. This is Arjun Mark I, a fearsome battle tank equipped with advanced warfare technologies.
So what are the problems in India when I first went back to India from US? I found that India was always anticipating war from neighboring countries, and they wanted to have advanced preparation. So I was called by the Indian ministry, and I was asked to develop different rubber products of DRDO. Not only materials development, which would have been much better for me, but they wanted me also to have the defense track trial in war zone, and then field test. So all this they wanted me to take. So that is the difficult part, because not only you have to work in the lab, but also you have to translate the technology, translate the science into technology, and technology into practice. So what was my motivation? Why did I take up this project? Because I have expertise on failure properties, and I could investigate the properties of rubber under critical conditions, plus contribute to national goals. So I took up the project after joining IIT Kharagpur. And so what are the criteria for such product? For example, you need high abrasion resistant compound, high tear strength, cutting and chunking resistant compound, and high thermal stability of those compounds. And in fact, we met all these criteria. We developed those compounds. And I'm not going to the details of compound development and testing in the lab. And these were first tested in the lab and then tested in the factory we had chosen. And then track pads were made. And we made track pads using 3 types of material: natural rubber, HNBR, and styrene butadiene rubber. And then we compared the results with the imported trackpad. And all these tests were done in the lab, and you will find that the % weight loss first in the lab and then in Avadi. And you will find that the results are shown here. % weight loss of rubber, right trackpad after 30 kilometers. The left trackpad after 60 kilometers, right trackpad after 125 kilometers, and left trackpad after 250 kilometers. And in all these results, you'll find our results are much better than those of the imported compounds. Those are being imported that time from probably Germany. And so you will find that our results were much better. So what happens, we are concurrently doing the scientific study. Now, when we get these pads, successful pads to defense, we get more time to do our research, publish papers. So one of the things I was interested in this project was, can we correlate this wear properties in terms of abradability, which is the volume loss per unit frictional work, with the fundamental parameters of rubber. And in fact, we derived a small relationship, which is given here, A proportional to 1 by G double prime, the loss modulus to the power 2 by 3. So we had all the compounds, all properties, abradability properties. We have the G prime, and when you plot it, that it follows exactly the same relationship. So fundamental properties could be correlated with the abradability of this material. But before me, people have done also abradability, correlated abradability with the breaking energy, 1 by breaking energy. And the plot is shown in this particular diagram. So all the pads are now sent to war zones for testing, and the life, we are not getting the results for 1 year. So what happens, we didn't know. And so I was under the constant nervousness whether this will survive. But later on, after 1 year, we found that life of our NR and SPR pads was more than 3 times when compared with the imported pads. So I'm very happy that I got a letter from Dr. APJ Abdul Kalam, that I'm very happy to note that track pad developed at your Rubber Technology Center and manufactured at Sundaram Industries and Mechan Engineering have been installed on the tank and subject to field trials. The pads developed have given good performance. In fact, it was more than 3 times the life they had given, and that's why they were not able to reply to me. The second example is an electron beam processing of rubbers and electron beam cured rubber products. This is a project I started with the BRC, Department of Atomic Energy, in 1990. This is typical electron beam accelerator facility at the time with BRC. What we are doing is we are taking different rubbers and then trying to understand the effect of electron beam on the properties of rubber. So we are mixing this, different types of sensitizer. One sensitizer is TMPTA here, and then we are mixing them and then making molded sheets and putting them into electron beam irradiation. And then at different dosage of radiation, different sensitizer doses, we are studying different types of rubber, polar, non-polar, all these rubbers we tested. And what happens, we are studying the structure property relationship. We are publishing these results in different journals. For example, here tensile stress versus elongation. And you can see that with the increase in electron beam dose, the stress value could be significantly improved up to a certain level, and then it decreases after that. Similarly, elongation at break decreasing with the radiation dose, and set also is decreasing with radiation dose. Now, these results are very interesting, and I was very lucky that this publications attracted the largest company, cable company, NICO Corporation in India. They sponsored a project with us to develop the formulation and processing of cable compounds using electron beam. And simultaneously, they wanted to make cables in the factory using the knowledge developed. So there were 3-party collaboration, IIT, BRC, and NICO, funding 50% by the company, 50% by the Indian Ministry, DSIR. Electron beam facility at NICO was purchased and developed, and operating conditions optimized by BRC. Our responsibility was to develop rubber compounds which would meet cable properties. We developed EPDM, CPE, chlorinated polyethylene, EVA-based cable compounds in the laboratory, tested the properties in the lab. The successful compounds were mixed, extruded, and tested in the factory. The cables were made in the factory. And then I found that I got very good results from the company. The company wrote to me that we have processed this further on a larger scale. And I'm happy to inform you that we made the cable successfully, whose properties are much better than the conventional cables. As a result, the company has decided to manufacture this commercially, and they used to sell this in the market. Right now, there are 6 to 7 companies in India manufacturing cable by electron beam, and I was the first person to work in the area of rubber cross-linked by electron beam. It's a factory they developed, and the cables are our innovation, and you can see that it's a typical new factory they developed, converted into old factory because it's very fast, and they could make a lot of money using this technology. This is typical property of chlorinated polyethylene-based cable compound. And you can see that in the middle one, we have achieved very good tensile strength properties, 17.2, MPa, elongation at break, 497% compared to the specification. We also got very good properties after aging, and electrical properties much better, oil resistance much better, and limiting oxygen index much better than the specification. So that's why it passed, and they use this compound for further processing. The third example, which is very interesting, because the other examples we had made product in the lab and tested them, but here I was asked to test the product directly in the manufacturing line. So that means if there are any problems with our particular product, then manufacturing will suffer, productivity will suffer. And so this is a project on development of rubber-clad roll for Tata Steel. That time, they were probably one of the largest in India, and steel is probably. Now, this is the Tata Steel diagram for rubber lining. In fact, you will see that there are a lot of rubber rolls they used in their plant. Ringer roll, squeeze roll, pinch roll, loper roll, brittle roll, various functions, squeezing, some for breaking and pulling, some for deflecting and rolling. And I got this message from Tata Steel that you have to have the best rubber for making the best steel. Because I'll show you the diagram where you will see that steel will have mark on the surface if you do not have the best rubber compound used in the manufacturing plant. And you will see that the number of rolls they're using, there are different lines, called galvanizing line, 1, 2, then pickling line, 300 galvanizing line of more than 100 rolls per year. And look at the cost, is a huge expensive affair for them. So these are the effects. You can see that the patch on the steel, stain on the steel, and because of the rubber rollers, they're cut, damaged sometime. And we did all the analysis when we took up this project. The challenge is how to improve the rubber roll properties under the prevailing working condition in the plant, and how to increase the lifetime of the rolls. In fact, this is a big project. I was their consultant for 15 years before I retired, and I developed the methodology for problem solving. We define the problem, project charter, we measure performance standard, data collection plan, we analyze performance objective, methodology, problem profile, failure pattern identification, failure mode analysis, identification of the vital few Pareto analysis, root cause identification. Then we improve characterization of the existing product, lab scale formulation of new product, accelerated testing in the lab under simulated condition, compare and suggest and plant scale production, and control plant trial, UAP formulation, regularize benefit calculation, and then audit. So we followed this procedure. We involved, initially we did all experiments in the lab, and then we identified two companies who could manufacture the product for us, and we guided them for best manufacturing practices to make these rubber rollers. And this has some of the results on our product. For example, we used for phase 2 of this project from December 2008 to January 2010. You can see that we have used Hypalon in ringer rollers, XNBR in ringer, XNBR in tension leveler, and the average life is 170 to 275 days for a roller, whereas the rolls that they were using, even the foreign rollers supplied by foreign countries, it was only 15 to 30 days maximum. In our case, XNBR average life 169 days, average life, original life was 15 to 30 days, and then XNBR in the tension roller 104 to 151 days, and then their life was only 15 days maximum. Sometimes 7, sometimes 10 days they were failing. So benefits of the projects with IIT Kharagpur. This is a slide provided to me by Tata Steel. Financial benefit, CGL1, CGL2 and the pickling line, PLTCM. You can see that 40 million rupees per year, 14 million rupees per year, 22 million rupees per year. Service life improvement starting from 250 to 600 in different lines, a reduction in roll consumption, downtime production, which is very important, 67% reduction in downtime, and scope for extra production, 7,536 rolls in CGL1, 11,000 rolls in CGL2, and PLTC in 13,000 rolls. We have 9 patents from this technology developed and still running. In Tata Steel, we have developed also a factory near Tata Steel so that their inventory is at Tata Steel is all gone. So if they want a roller, they will immediately order from the company, and the company would provide their needs. So this is how the arrangement was done at the end of this project. Finally, although I'm receiving the award, but there are many people, many companies, many funding agencies, many students, they are involved in my achievement, and some of them are shown here. And I must thank you for your attention.
With this last lecture, I again congratulate from my side and on behalf of INAE to all the award winners, all 7 award winners, and also thank Prof. Dr. J.D. Patil for giving me this opportunity to be part of this particular activity or in this session. It has been very interesting. I just wanted to convey to Professor Bhaumik that hope one day he will be able to develop time-dependent degradable polymers. That is what country needs. So thank you very much. We close this session now.
Thank you, sir. Ladies and gentlemen, we have just witnessed an extraordinary series of award lectures that reflect the depth, diversity, and promise of India's engineering community. On behalf of INAE, I extend a heartfelt congratulations to all the awardees and gratitude to each of you for gracing this session with your presence. Thank you. Ladies and gentlemen, we hope you enjoyed the sessions and the insightful lectures delivered by our distinguished awardees. I request all the awardees to please come center stage for a photograph. Thank you to all the distinguished guests and the awardees. Special thanks to Dr. P.S. Goel sir for chairing the session so wonderfully. Moving forward, may I request Professor Indraneel Manna, immediate former President of INAE and Vice Chancellor BIT Mesra, to please grace the stage and share a brief description of INAE membership on behalf of INAE Governing Council.
Good evening. I know all of you are exhausted after a very long and an extremely power-packed and information-packed session. We were very happy to celebrate the achievements of all the awardees, and I also can very well imagine that you must be looking forward to joining the dinner. This session is not going to be a very long one, but a very important one. So I seek your indulgence and patience for just another 20-25 minutes. We should all be aware that Indian National Academy of Engineering is not just a club of engineers. It's actually a peer group, a national level peer group devoted to the cause of the engineering profession. So in our few decades of existence, we certainly have come to be known as a learned body which caters to all aspects of engineering, divided into various engineering sections. And contrary to belief by some sections that we only are interested in electing fellows and giving awards, we actually devote more energy in identifying issues that confront the nation and demands solution. So engineering is all about finding out solutions and answers to the human aspirations. To be more precise, what we heard today from various awardees, including Professor J.B. Joshi, that despite being the 5th largest economy in the world with $4.2 trillion economy, India also has a flip side which says that we are 132nd in terms of per capita income in about 170 countries. We consume roughly about 1/3 of the world average of energy consumption per capita. The Human Development Index, Global Innovation Index, or for that matter, many other well-established economic criteria, India has a long way to go. A long way to go before we actually realize the dream of the Honorable Prime Minister to emerge as a developed nation by 2047, just about 2 decades away from now. And majority of the issues, whether it is energy, water, climate, defense, communication, transportation, habitat, majority of these issues are of engineering nature. And it is for this reason Indian National Academy of Engineering realized that with just about 1,000 fellows, no matter how well-meaning we are, we possibly cannot make an impact. So for a country of 1.4 billion, having just about 1,200 or 1,400 fellows as elected as 1,400 professionals elected as fellows, we count only as, by simple arithmetic, 1 in a million. So one may feel that way very exclusive, but it doesn't serve the purpose. So INAE, by the end of 2023, decided to create a new cadre called membership in 3 different groups: the corporates, the corporate membership, institutional membership, including R&D organizations, and individual membership. And individual members, in turn, could be coming as senior members, associate members, and junior or student members, depending on their number of years of experience from earning their last engineering degree. In this 1 year or little over 1 year, we could get about few hundred individuals selected as fellows, as members, individual members, about 30 plus institutional engineers, and a decent number of corporate members. So these categories have their own specific criteria and set of benefits that go along with these recognition. The entire idea is that on top of 1,000 fellows, INAE would also like to have 10,000 members, individual members. The main reason is to be able to reach out and to be able to address the major challenges faced by the nation through collective effort. So today, with the permission from the President, Mr. Patil, we are going to invite those who have been selected as members, coming from the corporate and also from institutions, but primarily confined only to the ones who are in the Bengaluru region. In this short notice, we couldn't arrange or invite all those who are spread all over the country. But it's important that we announce before this learned audience, particularly the fellows of the Academy, the main intention of INAE with regards to this new cadre called membership. For the individuals, I would like to clarify on behalf of the Academy that members are a parallel cadre, but different from fellows. And we are certain that there are very many professionals who are serving in industry, academia, or R&D organizations who have made a huge difference, a significant impact, but don't necessarily qualify to be elected as a fellow because the yardsticks and the criteria for election to fellowships are different. And at the same time, they make enough contributions for earning this recognition. So just like FNAE, they also would be allowed to write M-INAE. I request Mr. Patil to kindly come on stage, and we would like to invite the corporate members and institutional members, those who are present, to come and receive the certificates from the President. No, I just wanted, while you are on stage, I wanted to just show them 1 or 2 slides. Yeah. So these are the privileges, the benefits of the corporate membership and the 3 categories, the criteria and the fees associated with that. We are very happy that Hindustan Aeronautics Limited, our gracious host, is one of the corporate members of INAE. Next, MRTDC Belgaum, Dr. S. Subramanian, Associate Center Head. He's here. Yeah, this is, so Dr. S. Subramanian receiving the certificate on behalf of the MRTDC Belgaum. To apprise the audience about the list of corporate members and the institutional members. So these are individual members, senior members. The criteria for getting selected as senior members is that one would have served the profession for at least 10 years, passed the last degree of engineering. Yeah, they cover all the 3 categories: engineering, institutions, academic institutions, R&D institutions, and of course, industries. So these five, they have already been intimated. Another group of about 100. Okay. So these are the associate members. They would have acquired 5 years of experience from their last degree. And from various reputed institutions, not just academic institutions, but from institutions, from R&D institutions, industry. So these are 62. And on top of that, we have another about about another 100 who are at the last lap of getting selected. But this is quite small compared to the number that I mentioned. Our ambition is to reach up to 10,000 members. That will happen in course of time. We don't want to compromise with the quality, so these selections also go through a fairly stringent peer review process, which is overseen by one of the vice presidents. And through you, I would like to appeal to all those who are our fellows and beyond to take active interest in nominating individuals or institutions, even corporate or industries, for membership of Indian National Academy of Engineering. Thank you very much.